Oh, got a full tote class. Scooch in this way. Scooch you a little bit this way. No, you're okay. I'm just coming up. No,
I've got stuck on me on it.
Okay, there you go. It's cozy, isn't it? Yeah. So AT3.
You can borrow mine if you want.
We've got, just to go through the construction system from the ground up. So I have the drawings with you and the checklist if you need it. Not so much, but a little bit. And we mentioned yesterday when we were talking about the formatting of the report how a lot of the data is shaped by, or the shape of the report is shaped by the data that you get. That's pretty normal for any report that you might produce. You collect all the raw information and then you interpret it and analyse it and try and categorise it so that it gives the message that you want to give. This is a reasonably straightforward message. We don't need to infer too much meaning. We don't need to analyse the data to learn something new. We simply just want to take the facts and present them in a readable way. There's been a couple of issues where we've come across, say for instance like the toilet we were talking about yesterday, where we're saying the sketch plans may not be compliant, but that it's the kind of thing that we need to have a discussion with further, so we're making recommendations to highlight that. What I predict will happen in the reports for this one is that you'll address the warehouse section and the office section in different parts. There's an option there to have them as subheadings under the main headings that Sandra had up on the board. So footings, office, warehouse. Floor, office, warehouse. Walls, office, warehouse. So there's that opportunity. Or the other alternative is warehouse, footings, floors, walls, roof, and then office, footings, floors, walls, roof. So we just have to wait and see how it turns out, I suppose, to see what's easiest. How does that sound? Yeah? I'm just going to
always when you're writing a report, you have to think about the reader. You know, what's going to be easiest for them to, because you have to almost, it's really difficult because you have a lot of information when you're writing the report. So you, in your head, already understand what you're writing because you've got all the background knowledge, but the person reading the report doesn't. And it's your job when you're writing a report to make sure that you have laid out the information in such a way that it's easy to interpret for someone who knows nothing about the building, nothing about the project. So it's like you're becoming the lecturer or the teacher almost, and you're explaining that building to somebody else who knows nothing about it.
Yeah.
They probably just picked up the first project for the first time ever, and this is the report, or the client doesn't know about all these issues, or the certifier doesn't know about all these issues. So it really is just your description of where the project is at and what are the parameters of the project.
Yeah, quite right. And I suppose I'm automatically thinking as Sandra is talking, having the whole office section and having the whole warehouse section is logical. But it depends who's reading the report, because a builder is going to want to know what all the footings are. So it is quite tricky.
The structural engineer might want to see everything about the slab that you know, all the slabs, because you might decide, actually I'm going to join these two slabs together, or no, they do different purposes, I'm going to keep them separate, but you might want to read all about the slabs together, rather than having it has to go to two different parts of the report. So if it wasn't me laying it out, I would just do slabs and I would do office, warehouse, and I'd address the next structure, because really we're thinking about the structural side.
It's still a whole building.
Still a whole building.
So this report that we're putting together would be go to planning?
No, it's for the design team.
Just for the
it's to inform the
brief, really. So you've taken the brief of the client, you've done your analysis and your research, and you looked at the NCC and looking at basically outlining the parameters, and then you're just really returning that back to the design team saying, this is the result of my investigation.
Your desktop analysis,
At this point, nothing is really decided. It's really advice from you back to the design team.
Sharing what you know. Awesome. All right. So, to that extent, then we'll try and do it together. We'll do the footings, both sides, office and warehouse, and then work our way up and see how that goes. What class site have we got?
7B.
Soil classification, sorry. I should have been more specific. Do we know?
Should be in the breeze. F.
It was an F, I thought so.
Flat and class F.
So we're looking at reasonably typical designs for construction. We don't have to do anything extraordinary because of the soil classification. Site S is reasonably stable, and that's not surprising for the location. So Sandra just mentioned the first thing that would be up for grabs. Are we going to connect the groundwork? Are we going to connect the footings and slabs, or are we going to keep them separate? And that would probably, I mean, it's definitely an engineer's decision. It would probably help design the structure in the place where the two parts connect together. So you can see on the sketches there's some little eye drawings. You see those there? The eye columns, universal columns in the shape of an eye, where that's the frame of the portal on at the end of it. And then there's a double line which shows the blockwork of the office adjacent. See that there? Yeah. So you can see they're sitting adjacent to one another, but there's no indication at this stage as to whether they're connected or not. So that will certainly be something that will have to be determined at a later date. So we can't decide that for ourselves. Knowing what...
actually know that those, do we know that these office is blockwork created, or
Yeah,
we do know
yeah.
it's blockwork?
On the sketch plans, the hatching is shown
Okay.
for the blockwork. Yeah. On the elevations you can see.
Yeah.
Yeah, no, it's definitely blockwork. So does anybody want to have an educated guess about what the footings under the blockwork might look like, now that you know a little bit about blockwork? This is the third project, so you might already have a bit of an opinion about that. And thinking about the mass of the scale of the office, it's pretty much the same as a two-storey blockwork house. So it's not super weird. It's a reasonably straightforward construction system.
So what do we say about blockwork? Is it lightweight or heavyweight?
Heavy.
Heavyweight. And what do
Yeah.
we say about the foundation design for heavyweight?
Street footing.
No, not strip footing.
No?
No, that's
No.
more columns, the boards here.
No, think about the wall structure and what it needs to rest on.
We looked at blockwork the
It
other
will be
day.
this one, the thickened edge slab.
Mhm.
Correct. Yep.
With or edge beam slab.
Yeah.
So edge beam.
Or raft slab we call it, but thickened edge beam.
Yeah.
Yeah.
So you were halfway there, Sharon.
Mm-hmm.
The only difference between the strip footing and the thickened edge is the incorporation of the floor slab with it. But the foundation...
No floor slab.
Yeah,
Correct.
the
Yeah,
footing,
it's just
you
a footing on
fold
its
it
own.
back separately.
Yeah.
So you would use a strip footing. I think the other day we looked at where we had one blockwork wall underneath the elevated house, where we had a strip footing just because it was just one wall. But however, if we're having blockwork on all four sides, in normal blockwork construction, generally speaking, we have an thickened edge beam, and it incorporates the slab and all of that together is known as a raft slab.
It's a raft.
Raft slab.
Yeah.
Thickened edge beam.
And that will be at a depth determined by the engineer to be able to be supported by the soil classification and the density of the walls above it. Two-storey thickened edges don't significantly differ a great deal from single-storey. There is an extra load there, but the single-storey footing is sufficient to support two stories. I don't know whether that's common because a lot of people like to extend and have a second story sometimes after they've built a first story, or it's just the way it always is. But generally the 450 deep with 100 of the slab in there is sufficient to support the two stories. But like we said, the engineer will determine the depth. So if you draw a sketch of the thickened edge as a specification for the footing, the depth will be determined by the engineer. The floor slab will probably not be any different. It's 100 millimetres thick, typically. They might have something to say about the strength of the concrete though. That might be increased because it's two-storey. But again, not generally. Normally one-storey or two-storey, you can use the same strength concrete. What's the measurement for a unit of the strength of concrete again? MPa, megapascals, excellent. So that's an area pressure, kilonewtons per metre squared. Excellent. So we've got our thickened edge slab as a perimeter. Now we talked the other day a bit about shear walls and structural walls inside. So we know we've got a second story over the top of these walls. I'm just going to skip the walls downstairs for a minute and go to the next slab. We've got an extra level upstairs, haven't we, the mezzanine? What do you think that the floor of the mezzanine might be made out of?
Suspended concrete.
C-section, suspended concrete, yep.
I would say steel, like steel, I don't know, whatever, is it steel or beam? Is it a joist? That's probably the right word, yeah, joist.
Yeah. So we've got a framed idea and a concrete idea, yeah? What do you guys think? Framed or concrete? Framed? What do you think, Andy? Concrete? Adriana, what do you think?
I would probably go with framed.
Yeah? What are the benefits of framed and what are the benefits of concrete? What? Like as
lightweight.
Yeah?
Mm-hmm.
Yeah?
Less load on the walls below.
Yeah. What other benefits would we have for framed when we think about what's happening underneath? Because it would act as the ceiling as well, wouldn't it? So what benefits have we got?
Insulation, you'll have the cavity.
Yeah. And we'd probably be looking at this kind of ceiling, wouldn't we? So there'd be structure for that. The concrete does provide quite a bit of insulation and it also facilitates this kind of ceiling as well. So there's probably... What would?
Suspended concrete, wouldn't it?
The concrete would be a significantly...
Especially if you've got storage up there, people dropping boxes, and plus it would be stronger, wouldn't it? So if that's a storage facility and they're lifting heavy crates and stuff up.
You could make the steel just as strong. There's certainly some benefit to vibrations and acoustics that the concrete provides. That would be an advantage to the concrete, wouldn't it, Andy? Yeah.
You know, probably cost will determine that as well.
Maybe. I'd predict they'd probably be fairly equivalent, the costs.
So does it come down to what the engineer would recommend, or
perhaps? Yeah.
Well, if you think about the loads, you were right. The concrete slab has a strength in that the slab itself can, at any point of that slab,
in every place,
the load very evenly.
Yeah.
Whereas if you have a frame structure, the load strength is really starting to depend on the centers of the frame, as we already know, but also on what that flooring is. So if we think about a frame structure, what is the flooring going to be? Any suggestions? So you've got the crisscross of your frame work, with your floor joists and
the timber, the ply thingy. It doesn't have to be fancy.
No.
And so between the joists, that's the structure that's doing the work. Just that floor ply or CFC, more likely to be CFC.
So what are the options? We could have a timber floorboard, we could have ply as you suggested, or we could have CFC, which is a concrete sheet. We saw from CFC from the underside when we looked at the elevated house out on site the other day. Do you remember that? We looked up and we could see the timber floor where it met the CFC sheeting. So those are really your three choices for flooring in an industrial setting. I certainly wouldn't be putting a timber floor up there. It's just going to get scratched and things dropped
more
on
expensive than it needs to be.
So really our choice would be ply or CFC. And there's probably equal strength in both of those. Different.
But the comparison to concrete is quite significant. So concrete, like Sandra said, would be vastly superior in those places where the joists are apart and the ply or CFC is doing the work on its own. So I've built a mezzanine floor out of C-section with beams and CFC, and it's not able to store a great deal of stuff, boxes or equipment or anything like that. It certainly can store things, but there is sag pretty quickly because of those loads on the CFC. So I think for longevity and for disbursement of loads,
durability and hardware in the industrial area.
The suspended slab cannot be beat.
For quality.
So we've got something in between the floor slab and the suspended slab to keep them apart. We don't want them to sit on top of one another. There needs to be room between them for people and occupants and office chairs and computers and all the rest of it. What are we going to use to keep them apart? What did we say we were going to use? No, that's okay.
Sorry, can you...
What's keeping the suspended floor off the ground?
So this is your slab sitting up there?
Yep.
Stopping
Yep.
it. Yeah.
Yep.
Oh, no,
let's see, but it looks, that's the brickwork.
Blockwork?
Blockwork.
Yep.
Because it's also, yeah.
Oh, yes. Yeah.
So the walls downstairs, we're saying blockwork walls? Yep.
So are we saying that on the drawing here, are we saying that we've shown blockwork here and we can see this wall on the elevation? What about this wall? What's it going to be?
It's saying because it's a firewall as well.
True. So we're going to talk about perimeter blockwork in these areas?
Yep.
Sure.
Yep. What size blockwork?
All that blockwork.
200 series.
200 series. What is it? Is it load bearing or non-load bearing? Load bearing
and it will be
bearing the
reinforced.
slab above it.
What I call it?
Yep, core fill reinforcing.
Core we don't actually know how many cores are going to be filled. The engineer will specify that, but we
At
can
the minimum.
assume that there will be some cores filled. So we could say core filled, load bearing, 200 series blockwork wall, and that's the extent of the description that you need to be writing in your report. It's not enough to say 200 blockwork wall or load bearing blockwork wall.
Yeah.
I need to know the size of it. I need to all these details. Your description of the wall needs to be full.
It's likely that the engineer will specify how many bond beams they need. So we've got a elevation. We don't really have a section yet. It's too soon for that in the design process. But we have to specify eventually a wall height. So that will determine how many courses of blocks are above the openings. The openings in an office are at 2.1, typically the same. You might get a little higher for the main opening if you've got a special front door, but we don't really have any expectation that it's going to be particularly fancy. You can see on the elevation though, there's a bit of information about that. So we've got a maximum ridge height of 8.5 metres because of the planning scheme. And you can see that the pitch of the office sits just below the pitch of the portal frame. You see that there? So the top of the pitch of the roof for the upstairs sits just below the pitch of the gable end of the portal.
What does that tell you when you look at that? When you see that the roof is changing pitch? See the way it's pitching down evenly here on the portal frame? And then this is a slightly different pitch for this part here. What's that telling you about that point there? Anyone suggest anything?
Does there have to be something structural with that?
Absolutely, spot on. So you know that your portal frame is going to be going from this point to this point very evenly. Portal frames tend to be a mirror image of each other through their apex, and then at this point there's going to be a separate structure for this roof, but the structures are meeting at this point, and when structures meet like that, they need to be supported. So that's going to be a critical structural point in this building.
If we look on the floor plan, can we see where that column is? That's over by the loading bay. Because you can see on the front elevation, that's the roller door for the loading bay there, and it changes direction. And what's directly below that? You can see that there's a little row of columns to support that. See that there? This one? Yeah.
So the portal frame is very evenly being supported on two columns all the way up along.
Yeah.
Continues that grid.
And typically it just goes in one direction.
Yeah. And then through this point of where the portal frame is coming back down, there'll be other structures probably supported off these I-columns or universal columns, and then that will take a separate structural system for this little other bay or wing that's sitting out to the side of the portal frame. Can you see that?
So it's like a mini portal.
Because it's really important that you understand how that is working, that this is the portal frame and then this is a separate structure that's leaning, we call that a lean-to, it's leaning to another structure.
So we've got some minimum heights. If we were to predict or propose a minimum 2.7 high wall structure, let's just go with that for example, because blockwork works that quite well. If we were to have a minimum height requirement of 2.4 metres in the majority of the office space, would there be enough room for a suspended ceiling? What kind of air conditioning system are we thinking for this building, and is there enough room in the ceiling for the ductwork if that was necessary? So here you can see we have this ductwork outlet where the air conditioning comes out. There's lighting and diffusers and ventilation for return air, so we don't always just recycle our own air all the time. We have fresh air coming in that gets recycled in. But there's a fair bit of height above that before structure, and there's little hanging hooks that hold onto the frame. See these aluminium runners, the extrusions that just create the grid, and then the tiles just sit in them. They're not fastened in any way. So there needs to be some depth to that to allow for all the ductwork and lighting and things to go through. Is that the kind of system that we perhaps are looking for in this office? And how much room would we need to give for it if we were going to recommend that?
When we're thinking about ceiling height, what's the main difference between an office space and a dwelling, a residential, when we think about office space?
Non-habitable?
Yeah, they're both regarded as habitable. Habitable just means people occupy that space for lengths of time. They're both habitable. But I'm thinking about, when we look up at a ceiling here, what's different from your ceiling at home? Simple as that.
The type of ceiling, sorry.
The type of ceiling, yeah.
The suspended ceiling.
What might you see on your ceiling at home that you won't see in an office space?
Prettiness, trimming, plasterboard, like that sheeting.
Something else?
The aircon, I mean...
Fans.
So remember the 2.7 we need is a minimum for fans, but in an office space, we don't have fans in office spaces because it blows the paperwork around. So regardless, you're not going to put the fan in the office space. Nobody wants it. So that does mean that you have the opportunity to bring that ceiling height down further, because you don't need that extra 300 millimetres for the fan itself. So consider that as well. What height is your ceiling space going to be here? Is this office big enough to warrant a ducted air conditioning system? Or would you perhaps be thinking you're just simply going to use a domestic style of split systems in this office? That's also a consideration. It's not, if you were putting in a big university building like this, of course you're going to put ducted air conditioning in, and then you need the ceiling space to house all of that ductwork. But in a smaller office like this, you may or may not have such a system. The consideration for that then is, or the implications of that decision is that if you put a split system in, you must have openable windows. And a lot of smaller offices, they don't want the openable windows. They don't want someone coming in, switching the aircon on and opening the window at the same time and having condensation issues and mold issues and all the rest of it. So they want to have the sealability of the windows. And if that's the case, they need to have a ducted air conditioning system. Why do they need the ducted air conditioning system? Because the regulations for air conditioning would tell you that you need a certain percentage of fresh air. In our homes and smaller sized buildings where we have split systems, we do that by opening the windows. But if you seal up the windows, you can't just then put in a split system, because now you need to supply the workers in that habitable area with fresh air requirement. And the only way to have fresh air requirement built into the air conditioning system as we would have here is by having a ducted system that draws in fresh air. So I think it's about 10%. So every time it recycles the air, it recycles about 90% and brings in about 10% fresh air in each rotation of air. So there's a couple of considerations there that tells us why the structure will be what it will be, that we need to think about when we're deciding which way are we going with services. Because do we need the ceiling height? Do we not? What type of ceiling are we going to need? So you've got the background information, now it's time to make some decisions around all of that, and they're your decisions to make.
What do you think?
Oh, possibly suggest to still go split system.
Okay.
I was just thinking that the windows can be opened.
They do have windows there. It's
Yeah.
hard to tell because they're not louvers. It's hard to tell whether they're fixed or sliders. It is probably an option at this point because the design's still being pursued.
All
It's
options are
absolutely an
open at
option.
this
Yep.
point, but you have decisions to make in which direction you're going.
And I think it's a fairly even split between the two. There's no real emphasis. With the structural system for the mezzanine slab, it was fairly clear which direction to head in after a bit of discussion because of the loads and forces. But I think under these circumstances, it's probably a personal preference of the client.
So we could say this option or this option.
You could.
Per
Yep,
client's
yep,
choice.
yep, and just explain the benefits and requirements for both. That's an
So
option.
you kind of would just at this point say the ducted system implications, and then the split system implications.
Yeah. So the implications for the ducted system are a deeper ceiling space, which might necessitate higher walls, and that would have to be determined as to whether it would fit underneath the pitch of the roof. It's 8.5 metres, so I expect it probably would. And then the split systems would have to have the openable windows.
Which is an extra cost to the window itself.
Yeah. If it was a fire-rated wall, that would obviously be out because the fixed window is required. You can have windows, but they have to be fixed in place if they're fire-rated.
So you only have to have openable windows to habitable spaces. So the offices themselves, where people spend, 8 hours a day, you want them to have some fresh air during that time. But say, for instance, the kitchen. Personally, I would always put an openable window in a kitchen, but it doesn't have to be there. It's not really regarded as more like a tea room area. It's an area that's going to be visited. And the reception stands would also have to be openable.
And you've got that large
Got a door.
double doors. Yep.
Yep.
I would imagine that there would be some comfort in being able to open the windows in the dry season and some efficiency to be made. You just have to be careful with the way technology works these days. It doesn't like, direct sunlight or too much humidity or anything like that. So certainly in the wet season, it would have to be closed up and air conditioned. Lots of people expect to go to an office that is fully air conditioned 365 days a year.
Yep.
So it would depend on the intent of the client.
I think given there's nothing on the side where all the windows are in the office but landscaping, I think openable windows and doors and ducted system would be a nicer choice.
So the openable would go with the split system,
Yeah.
and then the ducted would go with it. Yeah.
Oh, did I say that?
Yes,
Okay, yes, that's what I
Split
meant.
and windows.
Having individual windows allows people to turn the cons off when they want.
Yes,
keep
yes,
them on.
yep.
So it's
Change
like
the
a
temperature
more kind of
individually.
Option.
That's also a really good point. Yeah.
It's a really good point. What I've found in my general experience is that it doesn't work so well in a workplace because you'll find one person wants the aircon on and one person.
Yeah, the splits will allow them to do that, but the ducting won't.
But
The
then
ducting won't, yeah.
I don't know. When I've been working in big office buildings, you end up freezing.
Yeah.
We have pockets of freeze. So as soon as you start creating partitions, because the systems are worked out for the whole room
open
to work a
plan.
certain way, and then you start partitioning off, it changes the behaviour of the system, and it's really difficult to manage.
And when the ducting aircon breaks down, the whole
office
Yep,
it's
yep,
hot. So
yep.
that's
Or just needs
flexibility,
maintenance.
The
Yeah.
upfront cost of a ducted system is much greater than the split system.
Yeah.
What about the maintenance?
Oh, and maintenance, absolutely ongoing maintenance. Always
Yeah.
with the ducted
Yeah.
system.
So
Yeah.
Yeah.
So there's lots
Yeah,
of
there's
reasons
plants,
why.
You need to find room for the plant room. For a ducted system, there's also there's a lot more than just what you see in the ceiling. All
Yeah.
those ducts need to go back to an air handling unit, and that needs to go back to some sort of other compression system that's actually cooling that air.
So we could
So there's a couple of
recommend
different ways of doing that.
to whoever his name is, we recommend that the split system list the reasons why, but write a note saying, however, client's discretion.
I think so. I think that would be ideal. Yep. The
So
deductive
two
system
different
is an
systems
option.
of what goes with which one. You know, ducted system, suspended ceiling, higher ceiling level of the higher level of the underside of the slab above, all of those things. And then the other option probably has a cost benefit, openable windows with the systems.
Individualisation.
Individualisation of the office spaces and backup for failure of the system.
We struggle with room in this building already as well,
Yep,
so
yep.
we would have to add another room or separate.
It can go on the roof.
Okay.
Yeah. So all those systems can go on the roof.
Also, didn't you say that we need like a room for ducted?
When you've got a ducted system, you generally have some sort of an air handling unit.
Yeah.
It can be either in a room, a plant room, or it can go out externally on a roof or something like that.
And then you have like a ladder
They
going
work a
up.
little bit more efficiently energy-wise if they go in a plant
They've
room.
got to be protected from
But
the heat.
they're often located on the roof, which isn't industrial building like this, not a huge concern. But if I was doing a church building or a community building or something like that, plant on the roof takes very much away from the aesthetics of the building. It's also noisy, so you have to start thinking about all those things.
The plant room for the air conditioning is right by my office, and it switches off at 5. And if you want to stay late, there's an after hours button. You can turn it on, and the button is right near the front, so it's this big square where I am. And so I walk to the front of the building, switch the switch off, and by the time I get back to my office, it kicks in, and it's this almighty screech that it emits from the plant room. And even though I know it's coming, it still makes me jump every single time. It's upset. But it takes quite a while to kick in, and then when it does, you can hear it just kicking in. It's massive. Yeah, it's really loud.
When you're running it, it'll be the entire space.
Yeah, it is.
It's more electricity than you're using, whereas if you
it's just me.
there's only one person in the office for that week,
Yep.
then you only need to turn the one aircon on.
Precisely, yeah.
Like a large area that is aircon, and it doesn't happen very often. This building won't have it. But the newer buildings, they start to zone the aircon. So you have zones 1, 2, 3, 4, 5, 6, and you can switch them on and off per zone. That's starting to be the way it's done now, but
that's if it's big enough though. They wouldn't do that for us.
Not for this one, no. I think my office has that because there are 2 switches and there's a map next to it, but I can't read, you can't tell which way up the map goes, so I just turn them both on.
So when systems become complex, service systems in commercial buildings, they really need a user manual, because generally the people using the building have no idea about the design of the building, and it isn't that in our industry that is not done very well to this date. You get more information when you buy a washing machine than you do when you buy a building, about how the services are operating in that building. So it's certainly an area that this industry could improve in that. A good user manual and good information being handed on throughout the life of the building.
Yeah, that's very true. So we're probably predicting that if they were split systems, the external units would sit on the elevation where the kitchenette and the toilet come out, because that's where the 5-metre easement is, and there's plenty of room and ventilation. So you could perhaps suggest that there's a place there that those external units could sit. And if you want to mark up the drawings to add those, that would be great. So you're looking at probably at a fairly large unit in reception, and then individual units in the offices, and perhaps the large unit in reception would do both the hallway and the kitchen. You're not necessarily going to put a split system in the air conditioner in the kitchen.
So 14. But was it like 9 metre?
Yeah, that's true. So if we were to put the split in the middle of the corridor, here, up high, the unit, internal unit, they're quite high, they're well above head height when you're walking. So if you put the unit here, that would then reach both areas quite sufficiently, I think.
How do you mark an aircon unit?
So it's just a box, and then you can put AC next to it.
Okay.
Yeah. So that, internal, yep. And then the same thing on the outside of the wall. I think one of them has a diagonal through it, does it?
Diagonal through it.
Yeah. Just the outside one? Yeah. For the external unit.
And the external unit is called a condenser.
And they have an isolating switch, so you can switch them off.
So what are you suggesting? There's one in each place, or because you just said that a large one here would
a large one here would service reception, kitchen, toilet, whatever, the rest of the space, and then an individual unit in both offices.
I wonder about this though, because there's a door there. in the kitchen to the kitchen.
You'd have to
It
keep
would
it
just
open.
be
Oh, so
left
it would be
open.
like
Yeah.
two internal units.
There would be an inside unit here
Yeah.
that would do all this space. We're less interested, we're less worried about the temperature in here,
Right.
but it would reach there.
Okay.
If all the windows were shut and the
Okay.
unit was on, but if they wanted to leave the kitchen windows open, they could just shut the door.
Would it really
And
travel
this
that
is
well?
Yeah,
Yeah.
I mean,
this
it's
is
facing
allowed.
the wall. Is it
Yeah.
really gonna?
Yep.
yeah,
Okay.
yeah, no dramas.
Nothing saying you have to have air conditioning in
Yeah.
the room.
Kitchen,
No.
but
Yeah, no,
No,
So just
no
if they
real
wanted
thing
to
you have
do-
air condition at all.
no.
But, you know. you do
And there'd
have
be a
to
benefit to having the unit further down the corridor a little bit. If this door is open,
Yeah.
close, open, close, open, close,
Absolutely.
you wouldn't lose the build-up of cold air. And then just one each in the office. That's only 3 units. That's a very inexpensive way
Mhm.
to condition the space. I think that would speak volumes comparison to ductwork. That would be a significant investment. So I have a feeling they would automatically go with the splits. And I do like the idea of the operable windows in the dry season. I think it would be nice if we could open these windows in the dry season and elect to turn the air conditioning off. It's just not feasible in such a big building.
I have a random question. I just thought of it. I was doing some markups the other day, and the engineer had done some markups on the drawings, and then he crossed it out and wrote STAT or something like that. Yeah, what does that mean? What does that
It
stand
means
for?
I've changed my mind.
Yeah.
I don't know
So
what the
go back to before. Yeah.
Like before.
But
Yeah,
surely
yeah.
that's an
Take it
acronym
as
for
it is.
something. Like, what
It probably is.
It is, I don't know what it is, but
I know.
it's a very common
Foster couldn't
thing to
tell.
see
He
on
had
the
no
market.
idea what it was,
Yeah.
and I'm like,
Yeah.
it really drives me
It just means
bonkers.
I've marked it, oh no, stat, leave
Yeah.
it as it
Why
is.
can't they just say
Yeah.
no or just cross it out? Like, why does it have to be specific? Like, it was for STAT.
T.
Yeah.
T.
It probably means something.
Yeah.
Yeah.
So everybody around the table knows
Yeah.
that stat just means
Yeah.
leave it alone. You don't have to do any more work.
Yep. I don't know what it stands for.
Exactly. No, I was looking through the books. I'm like, oh, what is it?
When you see them in social setting, just say, what does the acronym? Then let us know.
No,
Yeah,
everybody
yeah,
knows.
message Kathy
I
and be like,
don't know what it means
that
either.
means.
Yeah. Yep.
Yeah.
All right. Let's.
Statutory, is it?
No, I don't think so.
No,
No.
I don't know.
Google it.
You'll get.
Engineering
Engineering
language.
stuff.
Yeah, maybe.
Their own little geeky language, like that means.
I feel bad to ask them because they show like not professional enough.
Oh no.
No,
Yeah.
You have
Always
to ask, 'cause
ask.
you got to know what you're reading.
It's okay to ask. Yep.
It's okay to ask.
If something like as I mentioned is not clear, I will call and ask. But
Yep.
as STAT, I saw that before, but I
Oh, you have?
Yeah.
You don't know what it is either? No.
Well, you have to know what it is.
Nothing.
You can't send
Yeah.
it.
I'm always
address
saying,
it,
yeah.
address it.
Yep.
Like if you change it and write, because all he did, it was like a 112 and 24 or something like that, and then it was crossed out and then wrote stat, and I'm like, so do I just replace that with STAT?
Mm.
No, don't go writing
stands for,
STAT
right?
on your drawings.
It's a good question.
That's a great question.
So if we're not, it's likely we're not going to have the ducted ceiling, so the wall height will probably be okay at 2.7. But what will we do with the lighting then? Because you can see this suspended ceiling has the grid makeup, and there's spaces for lighting with fluorescent globes and diffusers. Can you see the grid above that just to help diminish the glare? If we are not going to have this suspended ceiling, we're not going to have that kind of light. What kind of lighting would we want in an office? And Sandra talked about lighting the other day and the way that you have to be able to see your work. That sounds pretty important in this office.
Task lighting.
Yeah.
absolutely, enough
What kind of
space.
lighting do you think we should supply for these guys?
But the light plane being at desk level is not for spaces, so. LED. One type of lighting.
Something similar. Like,
Yeah, yeah.
So fluorescent lighting is generally used for task lighting.
Yeah.
In work.
And you can hang them, you can suspend them. We've got the concrete slab, which is going to be our ceiling. So you're probably looking at just fixed, luminescent, what do they call them?
Lumen.
No, the
Lumen.
diffuser across the front. It has a fancy name. I can't think of it now, but anyway. Fluorescent, just check the spelling. FLOURESCENT. Fluorescent, is that right?
So a lot of cafes you go into these days, when you look up, you see the raw concrete underneath, and you're just seeing surface mounted, so mounted on the surface of the concrete, light fittings and services. And it's very industrial look. It's very fashionable at the minute to do that. You see lots of people like just paint
And then
all
they just
underside
like painted all black.
And
Yep.
I love it.
It's
I love the
it's
industrial.
absolutely lovely. Do you think that look would suit an office?
No. Oh yeah.
What
I've seen offices that don't even do that. They just have it hanging with
Mhm.
normal random ugly colours. I'm like, may as well just paint it black and white maybe.
Or what's the other option? If we've got if we look up, we can see the underside of the slab. What's the other option?
Still go ahead with this suspended ceiling.
It just wouldn't have to really be far, and you could
That's
be
true.
very small.
What's the other option?
space.
Apart from suspended ceiling, that doesn't have to be very far.
You can
Just enough for light.
button
And
plasterboard or
fantastic. Those are your options.
I was gonna say gyprock, but
Yeah, plasterboard's right.
Plasterboard.
You got it.
Yeah.
Yep, no brand names.
Plasterboard.
That's excellent.
So yeah, I would probably say in this instance that they probably won't go with the industrial look, even though it's a warehouse. In the office, they like to be a little bit tidier. So the cheapest option there is the battening plasterboard, similar to what you would do in a house.
And what we were doing in the
Plasterboard.
balcony of the Class 2 building.
Exactly. Yeah. And then we're just going to leave a small cavity. Probably the batten's going to be 40 mil, might be even down to 25 mil if it's just some electrical cable. So the fluoro fittings often are surface mounted on the plasterboard. So the behind the plasterboard is just the wiring and the conduit of all of the different services coming through. But then we don't really mind seeing fluoro fittings in an office that are just surface mounted on the underside of the plasterboard. That's not it's quite a common thing to see. If you wanted to get really fancy, you can recess them, but then the cavity or the batten size has to change because you've got to allow for the depth to recess the light.
well, you can hang them too.
You could hang them.
Yeah,
You could
you,
hang them.
you often see, yeah.
Yeah.
Just catches a bit of dust.
Yeah, and especially in an area where you don't have
Yeah.
fans. If you don't have fans and air movement, hanging is perfectly
Fine.
acceptable.
Yeah.
Just note that all air conditioning does create some air movement. So if it's hanging light is right beside the air conditioning, you're going to get the light moving around.
Turns
a bit.
into a disco.
Yeah, nobody wants to work in the disco all day.
Mm.
So some options for what we're going to do at ceiling level there. So I think structurally we're saying we've got block work on the concrete slab, and we've just had that little bit of a brainstorming session about how we're going to dress the underside of that slab, how our services are going to work in the office space.
So did you say that we mount the light to the plasterboard because it will it kind of hold
So if you use a 25 mil batten, you're really only talking about this. So the back of the light fitting itself in a recess fitting is probably deeper than that. It's probably 50 to 100 mil, depending on the light fitting you choose.
Yeah, they're quite deep.
They're quite deep. But
To hold the globe and the starter and everything.
If you want to recess it so the ceiling looks flush, because this is a recess fitting, and it's flush, you know, you can run your hand in that, a bit of groove in it with the grids and all the rest of it, but you know,
It's all the same level.
It's not hanging down lower than the ceiling level. But by surface mounted, I mean it will hang down lower than the ceiling level, surface mounted.
And the plasterboard will support it. They're not that heavy.
It'll be good up to the battens
Yeah,
that are
just go
behind
through.
the plasterboard. The light fitting will be. But the reason you have the plasterboard there is to hide all the conduit. Would you know what I mean by conduit? The wires and the electrics that have to go to the fitting to bring the power to it. We don't really want to see them crisscrossing all over the underside of the concrete. We want to use the plasterboard on 25 mil batten, I would say, with a surface mounted light fitting. As I said, if you want to recess the light fitting, your batten size would have to get bigger because you need more space behind the plasterboard for the back of your light fitting to recess it. What about the walls? What's the finish going to be on the walls? We've got blockwork walls. They're just looking a bit grey and bare at the moment.
Plasterboard, paint. I probably wouldn't go plasterboard because it's soft in case it's a workplace. But paint or you plaster, render it, it's kind of optional, whatever they want to go for.
So just painted would look like that?
Yeah. Just depends on
Client's preference. Yeah.
So what are the options you're going to put to the client?
What do you think, Nicole? How can we finish the inside wall in the office space? Yeah? What are
What
other
about-
options?
The bare-faced blockwork painted with paint finish. Bare-faced blockwork with paint finish. Option number 1. What's option number 2?
Render.
Render. And how would you finish the render?
Paint.
Render and paint finish.
You can batten it and clad it and use CFC for the cladding instead of plasterboard, which is a bit more hard wearing. So this is CFC here. Because it's a commercial space, it's probably quite wise, but it's certainly
if you're
doable.
going to have impact, you know, things are going to come along with trolleys and stuff, you know, the workplace is going to be really like that, then you probably want to go to something more durable like CFC as your internal lining, or plasterboard.
Yeah.
What are the 2 ways we can fix plasterboard to blockwork?
Glued.
Yeah.
Battened.
Glued or battened, yeah. So that's an option for the plasterboard. With the CFC sheeting, you have to use battens. You can't glue CFC sheeting; it's too heavy. So those are your options that you're going to put to your client for the lining of the internal office space, blockwork walls. What would we do with the blockwork that faces into the warehouse?
Leave it. To seal it.
Seal it. What about the blockwork externally? What's that going to look like?
Aren't we using the sheeting? Yeah, no.
Look at that elevation. What's that telling me? About the blockwork wall?
Oh, the blockwork wall. Oh, I thought you were talking about the warehouse. Yeah.
What do we do with
they've
blockwork
just left it
walls
exposed
externally?
painting.
Painted, bare-faced blockwork. Not rendered. If it was rendered, we wouldn't see that coarse pattern on the elevation. Just an aside, when I drive through industrial areas these days, I see lots of rendered blockwork externally, and they look more expensive just because of that render finish. The bare-faced blockwork has a bit of a budget look to it, and depending on who your tenants are going to be or what the purpose for this building is, you might want to advise your client that, you know, if you want to attract more tenants or different, you know, categories of tenants, you might want to apply render to the external blockwork.
So the office frontage is rendered on the lower level.
It is.
Or is it just not hatched?
Well, why would they hatch the top one and not the bottom one?
Well, they do. We often don't do the whole hatch because it makes our drawings look really busy.
Yeah,
So this is quite common.
Yeah, so wouldn't they have done that on the bottom if they wanted it continued?
A good draft person would, yes.
There's no guarantee.
But there's no guarantees there. But you're the draft person on this project, so you need to discuss that with your client.
It's on the other
Do you tell them to render some of it? Do you tell them to render all of it?
Yeah.
What's your recommendations to your
Yeah,
client?
you're right. Given that they've used that around on the other elevation for the external parts of the office, then naturally, I'm sure if they've followed it through everywhere else, why wouldn't they follow it through there?
Well, no, it is quite common that just that front face where the doors are would be rendered. Just to create an entrance. It's a bit of cost saving, isn't it, to create the entrance? But in these days, I see lots of these buildings being the office areas fully rendered. It's a bit of presentation.
Yeah. And planning would like that.
Yeah, but it's optional. You need to discuss with your client, and it'll all come down to cost in the end.
And what price that they want to pitch their products at as well, you know, are they don't want to...
Plus they want people to identify that that's where they go when they come on, like it's very easy and clear to see.
Yeah, absolutely. Absolutely. When we went to the office the other day, when we went to the warehouse, do you remember what that was? I think it was clad, wasn't it? Clad with the same cladding as the warehouse. Pretty sure it was.
Yeah, right.
Metal cladding,
Yeah, right.
I think I remember standing on the veranda and it was metal cladding because I was looking at the flashings around the windows.
Because that's
That's their business. I suppose they don't want to really bring blockwork into that. But if you notice when we went across the road to the kitchen workshop, they have concrete on their office and then they have cladding on the shed. It's quite common. Just want that office area to stand out a little bit and be a little bit different.
that was painted, wasn't it?
That was painted.
Yeah.
It's rendered and painted.
Or was it rendered as well?
Yep. I think there's some bare for the blockwork on the wall of the side wall into the workshop, and then the front where the door is all rendered.
So the windows, what are we thinking for the window frames and the door frames?
What's the material? Aluminium.
Yep, powder coated, most likely.
There is, so this one will have to be FRL.
That's a little different. Yep, it's a fire door.
And this one doesn't have to be as well?
That one, what do we have for that one? It's an exit, but it's not a fire door. So it's a fire exit, but it's not a fire-rated wall.
Yeah.
So it has special handles and works in certain ways.
And the exit side.
And the doors inside, office doors, they're not typically solid timber, are they?
Hollow core?
No. I'm just thinking about an office door. Sometimes they have a different material and different facets in them. What do you want to be able to do if the door's shut? Do you want to be able to see if there's somebody in there? Do you have maybe some glass, maybe, or at least some ventilation, maybe? Yeah. I think Sandra's office door has vents at the bottom.
The doors usually have vents at the bottom because it's ducted air conditioning. Because if they're putting air into the room and use the door closed, there has to be a way for the pressure of the air to go out, or else you end up with doors slamming and things like that. Generally to do with that.
You can have aluminium doors with glass, etched glass, like the...
Again, it's we discuss with your client, because sometimes offices are completely private and they can completely shut the door and be somewhat soundproof from everything going on around them. Or they want them to be quite accessible and open, and they want people to be able to come in the warehouse and wave in the window at you if you're on the phone and say, I need you out here, and things like that. Communication in the workplace itself.
Over in the carpentry office, which is similar to this, it's got an office space and then a big portal frame shed. The office doors have their timber, and then they have a frame around the fixed glass, and the glass sort of comes to sort of, I don't know, hip, sort of between hip and shoulder height. So you can see if a person's in as you wander past.
Some of the office, the clear glass, they will put the fin on it. Fin.
The fin?
Yeah, like obscure color.
Yeah.
A film?
Yeah. That's for privacy usually. So it depends on the workplace. Some people want the visual connection and to be able to communicate, or do they want that to be private? This is a separate space, and we need this to be silent, and where I do my business on the phone, and I need my privacy.
I think for me in an office, if I've got a solid door and it's closed, it doesn't feel very comfortable. If I had, whereas if I had a door with a window in it and it was closed, I would feel more comfortable. So without the window, I feel like I have to keep the door open. So acoustically and visually, it changes with every scenario. So acoustically, closed is better, but visually, glass is better for that. So then if you want visual, you don't get the acoustics when it's open. But that's just me. So it is up to the client.
We wouldn't have to worry too much because you have got that blockwork wall there. There shouldn't be that much noise travelling through, especially if you've got a suspended concrete. Yeah. It should be okay. The front door will be open quite a bit, but it should be all right. But you might find that they want to shut the door but still have that visual connection. Yeah.
So we can say aluminium or timber?
It can be timber or aluminium. It can be a frame with all glass and just etched in the middle. You know, there's all sorts of things you can do. Yeah, lots of door options.
I'm
And
just
you
thinking
can-
aluminium will be significantly more expensive.
It might be,
than
yep.
Timber.
Yep,
Timber
yep.
is like those
With timber with
normal
just a bit of
cheap
glass
ones
in it.
can be like
Yeah.
$100 when
Yeah, quite right.
aluminium is like a few hundred.
Yeah, that's true. That's true. Yep.
Yeah.
Not that much money.
So the main entrance door, what do you think about that in terms of glazing?
Yeah.
Have you ever walked into shops in Darwin where they've tinted the main entrance so much that you can't see inside at all?
No, you can
Can't
just
tell
see
if it's
yourself.
open
Yeah.
or closed.
Oh,
Yep.
And I hate going into it. I find them very unwelcoming. You know, I find that I'm going through this door and I have no idea what's going to meet me on the other side.
Yeah.
It's not a nice feeling. It's not very welcoming. So if you're a business, you know, you need to think about
Probably to
people
have
coming
a
in.
mild tint on it, but you want to be able
Mild
to.
tint
Oh,
is
yeah.
fine.
Yeah.
Yeah, absolutely. I tend not to go to businesses that are completely blocked out because I kind of go, don't know what am I walking into the workshop? Am I walking into, who knows who's in there? I don't know. Can't see anything. Don't find it very pleasant.
Yep. Good point.
So it is a business, and businesses should be welcoming for their customers because people who don't know the building well at all are going to approach the store.
Mm. So there's only one other place left downstairs, just the toilet, the disabled toilet. So you're looking at a wet area. What's the most important thing about a wet area?
Waterproofing.
Yep, waterproofing. Yep. So you can see there's a hatch image there already, which illustrates that they're looking at a tile finish. They're fairly small squares, probably a fairly conservative 200 by 200 white ceramic tile, reasonably in commercial, industrial, basic standard. And you're probably looking at simply just the areas that have to be waterproofed, not necessarily the whole room like we've been doing for our Class 2 bathrooms and our Class 1 and 10 bathrooms. So not so fancy. So you'll get a skirting trim all around the bottom, and if you're interested in what that would look like, just duck into our disabled toilet right here. So you'll have a skirting trim of the same tile. It'll be on the floor. There'll be the row above the hand basin for the splashback. And then if there's the shower area, then they'll have it around the shower as well. Ceramic hand basin, ceramic toilet pan and cistern if we're feeling fancy, or it might be plastic or stainless steel. And probably chrome or stainless steel taps and hardware and things like that. Probably not stainless steel.
It's
Cistern.
really prisony, isn't it?
Yeah, a little bit, yeah. Yeah, probably just a ceramic cistern.
So if you're ever working in remote areas, and we tend to use the stainless steel and that very industrial type fixtures and fittings for ablutions blocks out those areas, just because of the durability.
Yeah, can't break them.
A hole?
No, I don't think so.
Oh,
No.
yeah.
Yeah, we were talking about that. Yep, yep.
The shower.
Yeah.
So what other than
It'll just be a fall. Yeah,
Forward fold
and probably a shower
and a
screen.
shower curtain.
Yeah,
in a
yeah, that's what I
disabled-
meant. Curtain.
accessible bathroom shower curtain.
Yeah, just move it to the side.
And handrails.
And handrails.
Yep, handrails fixed to the
So you
concrete.
can just set fixtures and fittings as per Australian standard 1458.
28.
28. I
Yep.
get the next terms and the numbers wrong. Don't quote me on them.
And it'll be the same for the toilet on the other side,
Mhm.
or the extra toilet on top of that as well. Same tiles, same skirting, same hand basin and toilet and splashback.
All right, enough of those fancy finishes. Let's get back to real architecture and the structure of it all. So not true.
How thick
Structure,
do
not
the
finishes.
how thick will the suspended slab be, do you think? If you had to guess.
100, 150.
Okay, more 200.
Probably 200. Yeah.
Especially if it's going to be
If it's
load
like-
bearing,
Yep.
because it's going to have a lot of what we call live loads, so you know, loads that are interchangeable.
Just the mezzanine.
Yeah, the mezzanine floor. It kind of depends how far it has to span on its own. So if you look at the layout downstairs, we've got these walls that are right in the middle of the room that could support the suspended slab there for us. So we probably look at making those, at least the external part here, structural, to be able to support that suspended slab as well. But I still think it would probably need to be a couple of 100mm thick.
These two pieces?
Yeah, just this part here. There's an opportunity for a footing underneath there.
Again, that's really good to get
Engineers.
what do you want.
Yep. It's just for interest's sake.
Yeah. If you weren't doing load-bearing walls, what would your internal walls be made of? We decide that the slab, the suspended slab is going to span all the way to these blockwork walls. What would you make these walls of? They look like 200 walls on plan, but what's your option?
100.
Yes, but 100 what?
Partition walls, just like that.
Like this, yep. So
Yeah,
how is
right.
it constructed?
That's the wall.
What?
Pattern,
No buttons.
frame.
Wall framing. How wide is the wall framing? We looked at some of it when we were on site the other day in the warehouse. 76, 75, we generally use the term 75. 75 millimeters wall frame.
So internal,
Plasterboard either side.
oh, excuse me. Internal infill for commercial often use this Rondo product.
Yeah,
You'll hear that phrase quite a bit. Oh, just use Rondo walling.
yeah,
So it's not structural, it's infill.
it's a wall frame.
So it's lighter gauge steel than the truss and the blue coloured stuff that we've showed you. That's quite heavy gauge steel. It's thicker. The base metal thickness of the steel is thicker. This Rondo walling is a lighter gauge steel, and they just call it Rondo walling. Now, Rondo is a brand name, the same as Gyprock is a brand name. So you do have to be cautious when you're saying it. You just would call it non-structural steel wall framing, something like that. Yeah, it's quite thick.
This is our normal 75 millimeter stud, like the ones we looked at the other day. These are more heavy duty.
Yeah, you
Rondo
see the
is the
thickness.
same. You can see the difference in the thickness of this with the Rondo system. But Rondo system is a bit like a truss for a roof. You have to use their complete
whole
system. You can't
system.
just use one piece of it with
No.
everything else. You have
Yep.
to use the whole system. And it's like they'll come up with the wall framing system. They are certifying the strength of that system, like you do with a truss roof. You just bring it in as a system.
It has all the
You
different
just build
components
on
that
site.
go
You
together.
buy the components and you build it on site. The builder will be building this themselves.
And you can create curved walls with this. It's not a tight radius because obviously the Gyprock plasterboard has to curve around it and fix to it as well. But you can do small curves as well, which is quite good. And this other panel here has got some of the, I think this is the suspended ceiling dropper here. It doesn't normally go horizontal like that. It normally sticks out and down, but just shows some of the fixings and things like that. And some of the tracks and finishes.
So the internal wall, the options are, let's just say 75 mil stud wall. We usually call that a 100 millimeter stud wall, but it's important that you know that that's 75 mil of structure with plasterboard either side. Now the plasterboard can be 10 mil, the plasterboard can be 15 mil, so we vary that, but we still refer to it as a 100 millimeter stud wall. Metal framed stud wall. Or what other 100 millimeter type wall type could we have in there? Bricks.
We can't get bricks here. Yep.
Work again, but
Yep.
100 millimeter blockwork.
Yep.
Non-load bearing.
Yeah.
The 100 millimeter will not be load bearing. If we want any of those walls to be load bearing, they need to be 200 series. We've got the roof over the office space.
Just one second. Sorry, I just got one more little thing I want to say about water once everybody's finished writing. So just a little note here. Sandra's quite right in saying that 100 series internal blockwork is non-structural. Unfortunately, it's not very good for plumbing to fit inside. So if you've got a non-structural blockwork wall that has plumbing drainage in it, it needs to be a little wider. So there's an in-between series between the 100 and the 200, and it's just 150 series, which is 140 millimetres wide. So if ever you've got a non-structural wall that has plumbing in it, then you might need to consider just a slightly wider blockwork for that. So I'm just looking at this hand basin here. It might have water coming to it in the wall. So this wall here might need to be 140 series. 150 series, sorry, 140 millimetres wide. It's not too bad because it's only a hand basin. It's not a big toilet drain. So, and you might find that the drain itself might be external to the wall. It won't necessarily go back into the wall. It'll sit outside the wall and there'll be a cabinet over the top of it. So that's not too big a drama. So it's likely that the water coming down in this wall will be okay in the 100 series. But just a little note that I just thought of then to remind you is, particularly in residential construction, where you've got a wet wall, they call it, between, say, a bedroom and a bathroom, you might want to have a 150 series blockwork there. If it's not structural, but it does have a lot of plumbing and wiring and things in it, you just need a little bit of extra space in the cavity. Anything else in the downstairs? Covered everything?
I think that's pretty much it. I think that we need to think about the office area in terms of we've looked at the ground floor, we've got all our walls coming up, we've got our suspended slab at first floor level. What's happening above the suspended slab in the office area only? What's happening up on that first floor level? We've now got a slab. What are our walls made of going up to roof level? Sorry?
Very good. Just said, what about the floor finish?
Ah, yeah.
Yeah,
floor
quite
finish.
right.
Yeah, sorry. Floor finish in the office area. What would you think?
Like this one?
Vinyl, yeah. Vinyl's really good for just dampening down the noise. Lots of people moving around, and it's easy to clean. It's durable. It's got lots of
Vinyl.
Vinyl.
No.
V.
I know, because people are walking in there.
Although I shouldn't say no, like it never happens. In the offices, it can sometimes be a comfort to have. We've got them in our office as just the carpet squares, so that you can replace individual pieces. Or if the wear and tear in front of the door needs replacing, you can just do that bit. You have to make sure that design's going to be around a while. Don't go for something that's on trend and is going to vanish quickly. So yeah, carpet squares that fit together. Vinyl carpet.
Or tile.
Yeah.
Those are your three options, really.
Yeah.
Or big concrete.
Yeah. Polished concrete would be fancy. Very fancy.
Yeah, probably a little too fancy.
Watching them do that on a show the other night. I don't know what show, one of the English shows I was watching. They did a great job. No, actually it was Grand Designs Australia.
Yeah, right.
And they did it, so they had all the wet concrete and then they literally hand scattered the pebbles on top of it.
Oh, wow.
They were rough, so when it set, the pebbles were sticking out. It was quite gravelly and had rough edges. They weren't smooth pebbles that they threw on it. Oh, the finish they got off it was really good.
Wow.
Really even. I think the hand scattering was really even, and so they
wow.
Really play with the patterns.
though.
You use like different colours and
yeah, really good.
Then you can do all sorts of things with floors. You can add a top screed with, a resin and have a,
Colours,
colour and lights and all sorts of fancy
I was
things.
surprised by that, because there's a gardening crew that's opening up the resin floor thing, and I applied for them, but then
Yeah.
I did my knee, so I was like,
Yeah, that's fair. Yeah, resin, that's it. There's all sorts of fancy things you can do. Cool. So what were we doing? We were saying about the walls above the mezzanine.
So we've come up out of the office. We're now standing on this suspended slab above there, but we've no walls and we've no roof above us. How are we going to create them?
Still blockwork.
So still blockwork, okay. So the walls continue exactly the same blockwork. The finish on them up at this level will be just barefaced, painted maybe.
Sealed,
Might
yeah.
even be
most.
painted, just barefaced.
Yeah,
and
the
sealed.
floor will be the same.
And the floor will just be the concrete floor. So we really need to look at our floor, our first floor plan.
And there are windows up there. Plenty of light coming in. And so there'll just be balustrading there. The wall is on the same. It's on the same drawing.
It's got the mezzanine here. Yes, okay.
Just balustrading on the edge of the mezzanine, so the division between the warehouse and the mezzanine isn't clad over. There'll be the columns there, but it'll be exposed. So there'll be plenty of light coming into the warehouse through those windows, which would be good. Same kinds of windows, aluminium frame.
And they're on a grid to match what's on there.
Yep.
Yeah, more or less.
Straight up
Where they're
from
lined
downstairs.
up with the windows below. Always looks better in elevation. Try not to have your windows all staggered all over the place. It just looks like somebody threw them at the building.
Would you have fixed? Being a mezzanine, you wouldn't really need.
Probably.
Well, actually,
There's lots of ventilation.
There's
There's lighting.
designed as
I would have openable windows up there.
You reckon?
Yeah, because you know air conditioning up there.
And the hot air does rise.
And the warehouse is going to be cooled by natural ventilation by opening the roller shutter door.
Yeah, so you might as well have
You
more of
might
it.
draw some air. If you're stuck up there sorting out boxes all day, you might really want to be able to open the windows.
Mm.
And so, talking about natural ventilation in the mezzanine and the warehouse, what do we know works well with the natural ventilation opening the windows? How else can we assist the cooling of that area?
You wouldn't put a split up there, would you?
No air conditioning.
Air conditioning.
Like
You
a-
put big ass fan.
A roof
You
fan.
might have some fans. You might consider fans. You want to be asking your client, would you want or permit or... And often in warehouses we see wall fans as opposed to ceiling fans, because if we're lifting with forklifts and working overhead with heights or whatever, people up on ladders, don't really want anyone having an accident with fans overhead. Some big warehouses have the really big height, they have the big ass fans, but I often just see wall fans that are protected in some sort of a cage system, and they just move some air around to keep the workers cool. But it is an option.
So, recommend wall-mounted fans to be confirmed by clients.
Yep. What's the balustrading going to be made of?
Very standard industrial balustrading. It'll be steel. Can you guess what shape? Probably not even powder coated. Probably just the galvanized that it comes as from the... But what shape would it most likely be? Circular, yeah. It's very common. Circular hollow section for handrails and balustrades in industrial areas. Just round. And then you have the ball join over the top for where the uprights connect, and it just goes up and over.
So we
So
looked
it's
at
not
some
fancy.
steel balustrading the
Yeah.
other day. There was a good example outside the cabinet workshop as well. Remember we looked at the steel stairs that went up to the first floor level. So something along those lines.
I think I have an image for you. Hey, Ewan.
What's that stairs going to be made of now that we have managed to get up here? What's the options for the stair construction?
Big grey.
I mean the stair structure. Think about structure. So what's the two options for the stair structure? Steel or concrete. And we looked at concrete stairs the other day when we were out on site. You could have either of them. So concrete will give you the structure and the thread material and all of those things all in one. Do you remember we went to the elevated house and we looked at the steel structure for stairs, and then that just had some concrete threads on it and it was open at the back? You're actually not allowed to have it open at the back anymore in commercial buildings, only in domestic these days, so you're going to have to build up the thread and the back of the stairs. Given that we're having a suspended concrete floor at first level, for this project, I would be recommending to my client that we go with the concrete stairs, because we're going to be pouring concrete on site anyway. And that might work really well. So next, I really want to look at the structure of the building again. So we really need to look at this. So we know that we've got our universal columns coming up here that are supporting our portal frame all the way up along. Can we see that? Back here. So lining up our beams all the way along the building. Okay. I want you now to look at the office area. So we've got a portal frame here. Do you see this? See the I-beams are there?
Yeah.
So the I-beams are supporting the portal frame that is the roof structure at that location. So this blockwork wall doesn't have to continue to the roof, which is excellent because when we look here, we see that that's exactly where we want our balustrading. And so this, you can see the framing here is continuing up to support the roof. However, on this grid line, so if we have grid lines that would be drawn, we can see that the distance between this universal column here and here is very similar to the distance between this portal frame and the blockwork wall here. So our bays are quite uniform all the way down, even with the office space. That is for structural reasons. So then what we want to see there is that this blockwork wall is going to be structural all the way to the roof. There is no portal frame here. Can everybody notice that? There is no portal frame on that front wall. So we can say the portal frame is doing all the work in this area, all the way up to there, but it's not, it won't help us out here. We need the blockwork to be structural in that line. Any questions on that?
That's it. If we're using steel and not concrete, we're going to have to put like a kick plate on the back.
We are, yes.
Yeah.
Yes, you are. Commercial is no longer, you used to be able to do it, but they don't allow the open threads anymore.
Do they have kick plates all along the top of the balustrade as well? Because I usually would kick, like
No.
in case like falling objects.
No, I don't think so, no.
No?
Balustrade is fine.
But when you look at the elevation, this external blockwork on that wall doesn't reach over here.
So on your elevation,
What did I miss?
yes, sorry, you're right. You're very right, Andy. So the portal frame is extending to that line, the last line. And what's happening here is this, what's supporting this roof here, in this.
Well, that blockwork wall.
That blockwork wall. Yeah, so it's extending up to this roof as opposed to being part of the portal
Oh,
frame.
sorry.
Yeah.
I was.
No, you're right.
Yeah.
Because I was thinking it was this roof was going to continue out and this blockwork was going to go right up and be another bay of the portal frame. But no, you're right. The portal frame is stopping on that line, and then we're having this sort of lean-to structure that's going to come in and lean against the portal frame for support in this area. So here, it's coming in and it's going to connect in with the portal frame structure to support it. But out here, it's going to need a blockwork wall in this line. The front line of that front blockwork wall in front of the office. This is drawing right
I'm
here.
trying really hard to sketch this without making a complete goose of myself. So we've got the front blockwork wall, which isn't actually the front of the entrance, it's just the front of the building. And it leans up, like Sandra's saying, up against the portal. So there's two columns supporting the portal frame at the end. That's quite common. You don't just have the last bay on its own. It has to have some supports. So we have an opportunity, and we talked about, so the rafters, and did we decide what the rafters might be made out of? Did we talk about that yet? No? So let's say we've got something sitting on the wall, heading back here. It can't go to nowhere, and it has an overhang as well, because we've got some shade at the front there. So what we need is something going across here, don't we? For those rafters to go to. And then you simply just flash and clad around it. So there's a bit of cladding between the top of the roof and the underside of the portal. So this is the gable that you can see on the elevation. So you have cladding there on the outside. That's external to the building. So let me just turn that around so you can see. So we've got this big 2-story concrete box. And then we've got rafters sitting on top of that external blockwork, pitched up back towards the portal. What you can't see is probably a horizontal member that is in the plane of the portal that will take the end world of that rafter and fix that. It's not really a bearer as such. This is a rafter here, but this will just be a support beam for the rafters to go to. So they'll connect out here to the external front wall of the building, and then they'll weld to this plate here. So it might be SHS, something big and flat to weld to. If this is SHS, just depends on what the shape is. If this is C-section or Z-section, then there might be some cleats and bolts here. It just depends what the fabrication is. I would predict probably RHS rafters, if you wanted to particularly have them exposed and you wanted a nice finish, and you could have a plumb cut rafter end, or you could line this to feet. Either way, depending on what that structure looks like, then it would come back. And the blockwork would simply rise up underneath to match it. And you would cut those top couple of courses to match underneath. Normally, if you were cladding over that, you could just step the blockwork and leave gaps and flash over the top. I think we're probably going to render.
So you'll have those rafters.
Yeah, there'll be lots. I'll draw more.
Be all the way down, and then crossing back over them will be what we saw when we went out on site the other day, the purlins.
I've kind of drawn it a bit wonky.
The other direction, so that the sheeting can be fixed into the purlin. But the rafters can be square hollow section, it can be rectangular hollow section, it can be the PFCs that we looked at in the elevated house, so like it looks like a C, but it's the PFC, it's the heavy duty. These are a structural, primary structure.
I'll go
Do you
right
remember
here.
the universal column for that?
The rafter?
Yeah.
It's probably a little heavy.
Like an I-beam. Look,
You
it's
can.
not commonly done.
Yeah.
I don't see it.
And you see
Generally
PFC as edging sometimes,
yeah.
which is just an aesthetic, but it's,
Yeah.
it's quite overkill structurally.
Yeah.
But can look good.
PFCs and RHS and SHS are generally what's used for them.
Yeah.
The RHS and the SHS, the closed ones. Do you remember when I showed you when we looked at my house the other day, when we looked at the front porch, and I said I use the closed ones because the open ones often just gather lots of dirt.
Yeah.
So, you know, this is going to be the roof on that mezzanine. When you're up in that mezzanine working up there, if you want that to be a nice clean storage area, you don't want like a zillion spider webs hanging off your roof structure over your head. It's probably not going to be a ceiling. You're going to be able to look up and see it like we were in the warehouse the other day. We could look up and see all that structure. So, you know, you might want them to be closed.
Wasn't that, I mean, the warehouse that we went to, they did have I-beams, but then they cut it on an angle.
Yeah, you can finish it with a bit of a chamfer.
Yeah,
Yeah.
they did do that. Yeah, they did have the I-beams on the veranda. Yeah, you could use them. Yeah, you can use them. They're just not commonly used.
Okay.
Yeah.
They're quite expensive.
Yeah, okay, right.
You can have a copy of that, Andy. The photocopier.
It's $5.
Yeah.
But I suppose the main thing to note here is that you've got all these bays coming up to your portal frame, and then on the office is a separate roof structure. It's this structure here, which is supported and spanning in. This is the span, but it's coming from a blockwork wall and it's leaning to the portal frame. And inside that portal frame, we've got this other beam coming across that's taking the ends of the rafters on this lean-to structure.
And we will have hold-down connections to these rafters to stop it from flying away in a cyclone. Yeah. So it'll be held here, obviously, fixed. But here needs to be fully welded to the reinforcing that comes up in the core filling, and they'll just put it adjacent to it.
Yep. Do you remember when we were in the kitchen warehouse the other day, and we looked, so it had the framing system coming up, because we could see the, I think they were I columns, or universal columns, coming up, and then we had the portal frame. But when we got to the blockwork wall on the end, what they had done at the end, how did they fix those purlins into the blockwork? They had put just an angle piece on the blockwork. So you're looking at that, and the purlins were that's how they've connected into that block. This is a different system, but similar scenario where you've got a transfer of structure going from steel to blockwork.
Wouldn't they connect it with a saddle plate?
It's steel, so you can weld to it. The
Yeah.
saddle cleat's good for timber where you can't weld the
Yeah.
steel to the timber, so you have to bolt through. So
Okay.
this could just be on either side and fully welded.
Yeah, okay, cool.
Yeah,
Yeah.
you don't see that up and over with steel construction,
Yeah.
just timber.
Okay.
Shall we take some morning tea?
Oh yeah. What about more too fitting right into that next?
Oh, look, no. My little brain says, time's morning tea. I'm institutionalised. I look at the clock at 4:21 when it's time to leave so many times, it's not even funny. Perhaps, to support the slab and the walls and the second story and the roof. It's a prediction of what the engineer might ask for, but if that's a sensible prediction or a prediction that you're keen to make, then that would be the kind of thing that you would perhaps draw in your, and label obviously. The edge beam around the outside, and this is the shear wall footing. How do you spell that shear?
S-H-E-R-R. E-A-R.
Shear wall footing. It can be quite helpful to use diagrams rather than having to describe it all via text.
May I ask the section here? Would it be like this edge being here and
Yes.
then one
Yeah.
and then the
Oh,
other?
no, it doesn't go like this because, sorry, whatever that time. So this is correct, and then here this would just continue through, and it will just come down like this. There wouldn't no line here.
No
All
line.
poured as one.
Oh.
That's the line there. And so your internal wall would come down like that there, and your external wall would be here, and then you would go over to the other side. We'll just finish like this.
Another edge beam.
Another edge beam like that.
Oh.
But anywhere you've got an internal one, it just comes down and drops down like that. There's no lines in it. It's all one. When we pour everything together in concrete, there's no lines. Drawing it.
You can all take copies of that, it's no problem. All right, so we talked about rafters and likely C-section, RHS, or an I-section, and then purlins on top of that. And the purlins will be partially determined by what the rafters are made of, so the connections are easier. So if you've got RHS for the rafters, then you'll probably have a smaller RHS for the purlins, and then you can simply just fully weld them together, or you might have C-section with cleats and bolts, and then the roof sheeting on top of that. Have we got an indication of the roof sheeting yet?
So the difference with this steel, so this will be a hot rolled steel. This will be the thicker gauge steel. This is a primary structure. These purlins will be the lighter steel, the one we went to look at that is actually rolled in Darwin, the cold rolled purlins. So this is the purlins. We really see them as a secondary structure, if you know what I mean. All the strength is in the rafters.
Yep.
And then the purlins are just there to have the centre to centres for the sheeting, the roof sheeting to be fixed to. What's the centre to centres we normally use in Darwin? Colour bond custom orb, what is it? I don't know. Purlins that?
450.
No.
Oh, sorry, 900.
900 for the purlins.
For the
Yeah. The
Well,
steel
that's
to
it.
comply tells us that the custom orb,
Mm.
colour bond custom orb, has to be fixed at 900 centres. Remember we looked at how that was fixed on site the other day? So every 900 for the length of the sheet, but then across the purlin it'll be every second ridge.
This is the top
Story. Yep.
but then the
This is the front doors
Mm-hmm.
on this wall, on the short side. It's a terrible drawing, I apologise.
No, I think it's actually quite good.
So that's the front doors there on the short side, which is here.
so it goes
And this is the main length, and you can see the pitch runs from the main length back to the gable of the portal. So this pitch here is this bit here, this pitch here.
I get it.
Mm.
Yeah.
You see it back. Yeah. When
Yeah,
I
I
looked
get
at
it
that first, I thought the portal came all the way to the front too.
This is part of the larger system.
Correct.
This is
Yeah.
all.
Yeah, it's
And
in
this is
behind.
attached to the
Oh,
front.
Sorry.
Okay.
Yeah, now I figure it out.
Yeah,
Now I get it. It's like,
Yeah.
it is like, yeah.
Yep, perfect.
Yeah,
Next one.
and then it's like,
Yeah.
and then it's
Yeah.
like a roof.
So
Yeah.
you see why this is called a lean-to?
No.
Because basically this is the whole structure, and then you're leaning to that with this roof. Okay? All right with that, Nicole?
I thought that part was part of it.
Yes.
Yeah, that's
Yeah.
why.
You can
Oh.
often do that too.
Yes.
Elevations can often do it. Because remember when I said I was acting as part of it, the portal was going to come right out here, it didn't. It stopped there.
Yeah,
when
yeah,
it's to. Because I looked at that elevation and said, oh,
Yeah,
they're bringing
yeah,
it right
it looks
out.
like, because
And
there's no
it's 50%
difference in
shape.
line weights on the
No.
drawings.
It's a good point. So generally in elevation, if something is further back, we draw it much lighter so that the drawing reads like that. You can start to get a bit of perspective
Depth,
on
yeah.
and depth in your drawing.
What's going on here? What's that?
The line that's going all the way across. Is that a data
Got a
point?
name.
No, not the dashed lines. This structure here. You see that there? Look in other elevations to see if you can see what it is. What's that there? Yeah.
Awning.
Yeah. So it's like a mid-height overhang, goes all the way around. It stops at the firewall end where the easement is. It doesn't overhang there. You can see on this elevation, it stops here. You see it stops flush with the wall. They've got a pitch there, which I don't think is accurate. I think that would just be straight in the end. But it is an applied shade structure at the first floor height, isn't it? Just roughly where the suspended slab is. So you could render the whole face, or you could paint the whole face, and then they've just got this awning sort of sticking out. It's really good to shade the lower level of high thermal mass blockwork. It's really efficient.
Yeah. We were in the industrial area. Did you look at some awnings? Remember we said the difference between the awning and the veranda was that the veranda had some structure on its outer edge, whereas the awning was just cantilevered out from the building.
And this would be under those circumstances, wouldn't it?
Yeah.
So we've got this downstairs wall, and then we've got the floor above, which I'm not too concerned about because we just dealt with that. But at this level, so this is the downstairs of the roof, of the office, and then we've got the slab sitting on top of that, haven't we? And there's an awning coming out at that level, isn't there? Yeah. So it's going to be fixed directly to the blockwork, fixed directly to the concrete. It's not going to be a part of a roof system that sticks out like an overhang. Like Adriana said, it's an awning that's applied to the face of the blockwork. There are lots of ways that you can fix awnings to blockwork or to concrete, lots of ways. Typically they're a steel frame with a steel cladding. You don't necessarily need lining or anything like that unless you really, really want it. There's a good example just across the other side of the car park where it heads towards the trades car park and the free car park. There's an awning attached to a couple of buildings there that are easy to see, but you're simply just seeing a roof structure that's got a frame underneath it. You still need something for the roof sheeting to fix to. So you'll normally have a batten on each side of the intersection where it turns the corner, and then you'll have lots of them at what centres? For the roof sheeting? No. Let him. Yep. What did you say? Manhunter. Perfect. Thank you. So somewhere to go, but these have to have somewhere to go. So you'll often have either a beam across the bottom and a beam across the top to connect them to, and then support that. Am I drawing this right? Yeah. Upside down. I've never done upside down, 3 dimensions. Damn. Yeah, I don't know if I'm... But yeah, back to the wall. So that you've got an angular section back down. And you can have a plate for that to fix to, and then bolts for the plate, or you can embed that into the concrete when it's being built. There's all sorts of ways that you can do it. But there just needs to be a steel frame awning with cladding.
A frame, a steel frame with cladding applied to it, and you're just going to fix that to the wall with one point of fixing. It's not a roof overhang. It's not a veranda roof. It doesn't have columns coming down out of it anywhere. It's just got one point of fixing back to the wall. So remember we said on site the other day, there is very limited how wide the awning overhang can be because it's only got that one point fixing. It's not particularly strong. If we did have columns, we can bring that way further out. And then we looked at the shed right beside the metro, and that had a big awning and it had big columns coming down, and we noticed the difference between that and this type of awning where there's no columns. We just have it over a roller door, for instance. I think the one we looked at was over a roller door. We said we wouldn't want columns there because you're probably reversing big trucks in, so you just want an awning that's hanging out and overhang over your entrances and doors. But they are limited in how much they can span out from that wall because it's a weak connection. It's a one-point connection.
So it's not actually part of the structural system.
It's not the primary structure, it's added on.
Okay.
It's an add-on. An awning is an add-on. It it has its own structure because of the framing it has for itself, but it's not part of the primary structure again. It's not holding up the roof or anything. It's doing its own thing.
This is just a suggestion. So I've got the external blockwork wall, the suspended slab on the top of that, and there'll be reinforcing coming up and going across, and going across and going up to the next wall as well. But there's just a plate here, and that's bolted into the blockwork. It has to be a core-filled beam. It can't be a hollow block for those bolts to go into. And then you weld the RHS to it and just cantilever it out. You cut that end so it looks nice, fix a batten at top and bottom. This is a 900 overhang typically, and then apply the roof sheeting to that. It's all welded and bolted.
Did we discuss how many closes of ring beam?
No, the engineer will specify that, but it'll most likely be all of the courses above head height. So if we're having
there's
27.
a lot of fixing. See that plate is every time you've got one of these pieces of the frame coming in, there will have to be another one of these fixings into the blockwork. So that whole course where that's running along has to be course in, so you can drill and bolt into it.
Yeah.
Sometimes the engineer will require a support back to the wall.
We do. We saw that the other day actually. We had a 45.
Do the same thing with the bolt.
Yeah. So that gives it a 2-point fixing. But that 2-point fixing still wouldn't be as strong as where if you had a column coming down here and it becomes a roof structure. It's not a roof structure, it's an awning structure.
Columns.
Is that clear to everyone about the different fixings for awnings to actual veranda roofs? We saw it the other day and now we're looking at it in how it actually works structurally.
I think we've exhausted the office construction. Surely we're done.
I think we need to be done here.
The underside of the roof for the mezzanine can be exposed. So what was it you were saying about dust and spider webs and things like that? Was that to do with that?
Just if you're going to expose it and it's say somewhere like a mezzanine, it depends what you want to use the mezzanine for. If you don't mind your mezzanine being all dusty and a bit like the warehouse.
Some CFC lining would probably suit.
But I would just enclose the members, so I'd make sure they were rectangular hollow section or a square hollow section.
So there's no shelves.
So there's nothing for dust to catch on to. It's just the beam in itself. It's closed in. And then I would drape my isolation over the purlins. Remember the isolation? You know, when you were in the kitchen workshop the other day and you looked up and you could see the silver in between. I would just be happy with that that gives us the reflective foil insulation. It's making that a little bit cooler there. Remembering it's a non-air conditioned space, but isolation works very well for that. You get a 5-degree reduction in temperature with just isolation in a roof like that. You want to. It
would be very hot otherwise. It's just a single skin of roof sheeting between you and the outside.
If I told you to go out and line the car park and hold a sheet of tin over your head for the day, that's exactly what you're building here. So, put a little bit of isolation will take the temperature down in there. You're going to ask people to work up there in the roof space. Sometimes
you'll see in commercial buildings a light gauge steel mesh underneath. You saw that?
We saw that on site,
and it just holds that ponded isolation, so it might go underneath the member so that you're not reducing the gap. It can create a galvanic reaction between the mesh and the isolation, and then you end up with the squares of silver coming down like confetti after a few years. So they've made some advances in being able to hold that in place and not have it. So it's quite good. Just a way to support it. It's just fencing mesh. Yeah, really light, big squares, just light mesh.
Do you all remember seeing that the other day?
But your one looks like pretty tight.
And we discussed a bit that if you put the safety mesh over the purlins as well, it doesn't allow the isolation to drape as it should do. But they're both requirements. They're conflicting with each other.
Yeah, it's difficult. Excellent. All right. Portal frame?
Portal frame.
So it's funny actually because we were going to do all the footings and we ended up doing all the office.
Yeah.
That's funny how that went. Not to worry. So what somebody already mentioned. So what's the footings, the main structures footings that we're going to be dealing with for this one?
Portal frame. What's coming down to the ground? What's the one piece of structure that hits the ground? If you look at the floor plan, we can see it. Columns.
Yeah, we've got columns. What sort of a footing will we have for those columns? Yeah, board pier footing, absolutely.
Board
So we've talked about this a bit already.
Oh, no, board pier yet?
Board because it's B-O-R-E-D.
It's like board.
Yeah, board. Yeah, B-O-R-E-D. Yeah.
Ah, yeah.
So who can describe what that might look like to me? I'm sketching. Describe as I sketch. What's inside this cavity?
Concrete.
Before the concrete?
The thing.
Yeah, go on, Adriana. You're right.
Steel spiral reinforcement.
Oh, not spiral, but definitely steel reinforcement.
Oh, yeah.
Like a round.
It's gonna have a base plate.
No, no base
No,
plate for this one.
The column. What is it?
No, just talking about the footing for
Just
now.
for the footing. Okay. I mean, like the column.
How am I doing so far? What are you seeing there? Remember I've drawn this a couple of times on the board already?
Yeah.
We've just got this really deep, fairly narrow hole. Yep. And what are we trying to do? Because what is a portal frame in the end as far as a cyclone is concerned? It's like a big umbrella, isn't it? Just wants to pick it up and carry it away. It's very lightweight construction. So we're creating this huge, big umbrella. And you can imagine the slightest wind that comes along would just pick it up and carry it away. So this is what's going to prevent that. So this is the ground level here. And this is below ground, because for the height that we go to, we have to go further and further into the ground, and we've got to stick that connection in there, don't we? So it's very difficult to connect above ground and below ground in one step. You have to break it up into two steps. So we do what's below ground first, we create something at ground level, and then we fix what's above ground to that once we know what we're doing. So what we've got here is a big steel plate, probably quite thick. It's a little above ground. Apologies, it's a bit deceiving by my weird drawing. But it's a little above ground level because we want to build a little concrete plinth under there that will end up looking like this. Because when water hits it, we want the water to run away from the steel. So we create a little sloped footing.
Slightly wider than the steel, and we create a slope in the concrete, and then the steel plate.
And then it will shed water.
Sheds it off the concrete.
So we might have a finished floor level like that.
Look, at the depth of the plate is probably 20, 30, maybe up to 50 mil, depends on the size of your portal frame.
Yeah.
And then that little depth of the concrete coming up is about the same. So
Yeah.
all of that is maybe only 100 mil above the ground level. And then you've got your little bit of concrete that slopes down, and then your little plate sitting on top of that.
But it's enough to keep the water sloped away, sheds water.
And if you go out on site at that point in construction when they've just put the footings in, that you'll see exactly that above the ground. You'll just see a series of plates exactly where all those columns are going to go.
But the bottom of the plinth level is level to the base of the floor slab, yeah? I mean the top of the floor slab.
Floor slab, yeah. Yeah, the ground level might be slightly lower.
Lower, yeah.
That's right.
So at least this kind of footing is under the columns.
Yeah. So anything that's a column coming down, it's a point load coming down, you would have that type of footing. Yeah.
So I've got these huge long pieces of reinforcing. This could be up to 2 meters deep. I've got these really long, thin, cogged, C-O-G, cogged reinforcing bars that are coming out through this plate or welded up underneath that plate. But they're just kind of dangling like spaghetti. Is that okay?
No.
No, we have to put the
Ligatures.
Yep. I'm going to have to put a muzzle on you, you are, so other people have an opportunity to talk. I love that you know it. L-I-G-A-T-U-R-E-S.
Ligatures.
Yeah.
And cogs are the other little one at the bottom.
Yeah,
Turn,
they just turn them out,
angle.
yeah. So the engineer determines the location of the ligatures, the size of the reinforcing, the depth of the footing hole, the width of the footing, the works. But if you have a bit of an idea that that's the kind of footing that goes underneath under a portal frame column, you will be doing really, really well.
It looks like a cage when it's all set up, all that steel work. It just looks like this square cage that you stick into a round hole.
Yeah.
And then you
fill it up with concrete.
Fill it up with concrete. Leave your plate on top.
Got to leave a little bit of a gap between the bottom of the steel and the bottom of the hole so that concrete can fully encase the reinforcing.
Because you certainly don't want the steel being in contact with the ground. You want the
No.
steel to be fully encased in concrete with a 50mm minimum cover. That's to prevent rust.
Mm.
Why do you think we leave the plate up above? What's the plate for? Any suggestions? You know, like
I'm not going to.
Thank you, Juan. You're very sweet.
To the plate.
There.
It's to allow the connection point.
So that's the edges and the web. So in plan view, there's my plate. Here's my portal frame column, universal column, in the shape of an eye.
See that shape of the eyes all over the plan.
Yeah.
So that's coming down, sitting on top of the plate.
This edge here and this edge here are what you can see in the double, and this big piece in the middle is this big piece in the middle. And then you normally get the reinforcing up through the plate, and then you bolt that. So the top of the reinforcing can be threaded up the top. It's not always the case, but if it is, then you've got that coming through, and it gets bolted on each side to connect the reinforcing to the plate, and then this is fully welded to the plate so that your hold down connection is intact. And these are the kinds of sketches that you can include in your report. Not my sketches, obviously, your own sketches.
Could
Good
we
practice.
do the details, like a detail for that section on Revit and then snip it and put it in
If
there?
you like, any way you like, no problem. So that's bolted through.
My drawing's terrible.
And then it's bolted through.
Yes.
Yes, no problem. What you have to be careful of is there's got to be enough room, and this is not your job, but just be aware of it. You've got to make sure there's enough room around those bolts to do the fixing. You actually have to be able to tighten them. So the tool that you use, no matter what it is, has to be able to get between all these pieces. So sometimes the footing and the plate is determined by the bolts and the UC, not necessarily the uplift. Anybody have any questions about that?
Please never be tempted to cut the bolts off for any reason. I have seen projects where
Really?
people want to have nice flooring, and the bolts are sitting on the outside of the plate, and they decide that, you know, they can bring the flooring up over the plate to cover it, and then the bolts are still there, and they might want to chop them off.
Oh,
Don't
no.
ever be tempted to do that. It's a structural connection there.
Really? I've never heard such a thing.
Yes.
Oh my. Oh, we don't need that structure. Just.
Can we cut the bolts off? They just trip hazard. Can we cut the bolts
Oh
off?
no.
Yeah.
Wow.
No.
Yeah, that's a big old no.
The answer is no.
That's a big old no from me.
Trip hazard if it's already on a plate.
Yeah.
That's where they want to dress it. Yeah.
Don't stand against the wall.
That's madness.
Box the whole thing out and leave it in the box if you want to do that and floor it in your box.
I've seen that where some places
it is
just
very-
attach like a I don't know, cut off a plasterboard or
Yeah,
chipboard
around
or
the
something,
column.
and they just go around the bottom of the
The
column.
box out the column. Yeah.
Wow.
So this is very industrial. It's a warehouse, and we can leave these things exposed. But you may be using a portal frame. We've used it in lots of the educational buildings here. So you're doing a full finish fit out. So then you have to think about how am I going to deal with this plate that's not very pretty, and you know the big I beams as well.
Wow.
I have been asked.
Oh dear. That's not good. So you can't often attach roller doors to this structure. You'd have to add another structure on for the roller doors. So if I have an eye in my section, I might need to put an RHS piece welded to the internal web member that gives me somewhere to put the track for the roller door, because the roller door goes down a track that keeps it in place. So if you push on a roller door when it's shut, it doesn't swing in like a curtain. it's held in place by a channel that it sits within. So when it goes up and down, it sits inside a channel. So that channel has to have somewhere to go, but the web members are quite deep on a universal column. So you might have to have a piece of RHS that goes up and across. You need something across, obviously, as well, and down, and then that will become the frame for the door, and then you can bolt or weld the channel for the roller door, and there's your roller door in there, and then across to the other side, and you'll have another one. So they're usually a full bay, the roller doors, and the bays are often determined by the size of the roller door, simply because it's convenient. If you didn't use the whole bay for the roller door, you would have to have some other structure between the edge of the roller door, more structure between the edge of the roller door and the universal column that had the frame of the bay. And that's a bit expensive and unnecessary. So they simply just pick roller door sizes. So there's standard roller door sizes that can span all that way, and it depends on what kind of roller door you get. So there are roller doors that have single sheet profiles. Whew, okay. We're going with it. Just very straightforward single sheets. But that's not all that you can get. You can also get other roller doors that are much more heavy duty, and they're made with single pieces of steel, and they grip together like those monkey grip games, the Barrel of Monkeys. And so they're all individual pieces of C-channel that are curved and made proprietary like that, and they all slide in together. And if you break one, you can just take one out and put it in. It's quite good. And the likelihood of bumping into roller doors in a forklift operating warehouse is pretty high. It'll be, lots of high-vis tape everywhere and everything, but my mum backed into our roller door. Yeah,
lovely bright colour.
Yeah, that's right, yep. But these are much stronger and can span a lot further than these ones. A lot further. Under wind loading, holding its own weight, or just being good security, these do a lot better work. They weigh a lot more, they cost a lot more, and they go a lot further. So quite likely the roller doors that we're seeing is this kind. So when you're researching roller doors, yay research, when you're researching roller doors, keep that in mind. Have a bit of a look and see what the maximum span is. Now these ones here will go up to almost 5 metres. They can go a fair way, but you can imagine if you were looking at breaking in, you could just back into it with a car probably pretty easily. And I don't imagine this facility is going to want to have bollards outside their roller doors because they need easy access. So we're probably looking at more heavy duty roller doors, and they are quite tall.
What is it called, this one?
I don't know. Yeah, unfortunately.
Monkey grip.
Yeah, I don't think it's called monkey grip roller doors.
And also when you're specifying roller doors, if you're looking up the data off any of the manufacturers' websites, make sure you're looking at the roller door range suitable for cyclonic regions in Darwin.
It is very different.
They have a different locking system at the side of the door that locks that door in at much more regular intervals.
Yeah.
Down south, they tend to just hang the doors on. They're only concerned with somebody.
They just have a back.
Into them or pushing into them.
They don't have the channel. They just have a plate to go up against it. Just to run next to it.
We have a full channel down the side of the door because roller doors are actually very vulnerable for that wind loading that we experience in the event of the cyclone can push the whole roller door in. So you can imagine if in a big warehouse, like we said, it's like an umbrella. If the roller doors give way, that uplift is now underneath the roof. It's not just around the building, it's underneath, and it's underneath your umbrella. We all know what it's like to walk along with an umbrella and the wind gets underneath it. That's what we don't want to happen to our warehouse.
No.
Roller doors are one of the weaker points of the warehouse.
And they didn't perform well under recent Queensland cyclones.
No.
Yeah, roller doors and garage doors and things were particularly vulnerable. So
in overseas, I don't see this here at all, but overseas in buildings of this nature where you just have a big supportive frame and you've got just metal cladding and roller doors, there's been lots of like ram raids, so people drive their vehicles through the roller door. We probably get away with that here a lot because of the cyclonic nature of the roller door. I don't think you'd want to do that in a car here.
No, damage
your
car.
Driven through. So when we looked at the warehouses the other day, we've got these big girths, the wall girths, like the purlins in the roof, the girths that go across, and they just go across between the universal columns, and then you've just got roof sheeting. If you were to hit that structure hard enough with a car, you would go through it. It's just wall sheeting and some purlins or girths at wall level. There's nothing else there, you'd hope that your would-be intruders would hit the bracing. Would be really nice for them because they won't know which bay the bracing is in. But if they go to a bay that doesn't have any bracing, they'll get through it fairly easily. If you're ever designing a warehouse or a structure like that needs to be a bit more secure, like the one I've worked on previously, like stored lots of alcohol, and they, you know, really want to make sure that, you know, nobody's going to just drive through the wall and take the alcohol. You can do block work, maybe 900. And then do your sheeting over that. So you can infill with block work. It's not structural, it's just an infill of block work. Or you make sure that you've got your building at a maybe slightly higher level. So they'll hit the side of the slab. The car won't be able to come into the slab, and you can maybe have steps up to it. That gives you other issues with, you know, accessibility for loading and unloading trucks, but sometimes that can work as well. But yeah, just to be aware in warehouse development, that security can be an issue. It's very lightweight construction. It doesn't seem to be an issue, Darryl.
No, thankfully. So Sandra just said the word bracing. What did you think of when you heard that word?
Dun, dun, dun.
We looked at lots of bracing the other day on site. Does anyone remember?
Yeah.
What did it look like?
Cross bracing.
X marks the spot. Really? That's excellent.
Yeah.
Hence the dum-dum-dum. Terrible drawing. How many bays do we have?
There was slab bracing and cross bracing.
Ah, what's there now?
Point out both.
How many bays do we have?
We
Nicole, how
have-
many bays do we have? Put you on the spot there. Just the main rectangle. These ones here. So the bay is the gap, if you like. So 1, 2, 3, 4. Is that a gap? 5, 6. Oh, good. Not enough. Apologies.
You can do the same thing.
It's just a duplicate. So I've got 3 bays. It'll be a
Double it.
double-sided one. Yeah. Go on then. They're not this close together. The proportions were right, but I've lost them. So that's okay. So we've got, this is our portal frame. This is all there is to it. Huge open column-free space inside. That's the portal frame shape. That's really all there is to it. But you can see that it needs some support, doesn't it? It couldn't do its own work. It's not just going to stand there like that. That would be like expecting a piece of paper to stand up by itself. It's not really going to work. So we've got these pier footings below them to stop the uplift. That's good. What else do we need?
Cross bracing.
Cross bracing. What do we do first? If you were building this, what would you do first to get them to stop them from falling over?
Oh, okay, so put the roof.
Because you'd build one, wouldn't you?
What's the name of them?
And then you'd build the next.
What goes between them?
How would you join them together so they didn't fall over? Nicole? You were going to say? How would you... No, that's okay. But what is it? You want to point? Which structure would you build next? Yeah. Purlins. Yeah.
The roof, the purlins, or
Yeah.
the walls, the girders?
So once you join these together, one on each side of the ridge, that would be a good start, wouldn't it? Just the two together, then you've started to got a bit of a box, and then it's less wobbly. Absolutely. So we'll end up with purlins all the way along.
What do you call it for the walls again?
Girders. G-I-R-T.
What centres are our purlins again? Dude. And so what? Yeah. And what centres will our wall purlins is what you'll hear. Not everybody knows Gertz, so that's a good trivia thing, you know, at the pub. What centres will our Gertz be?
900.
Nice. So you normally just start a couple of 100 mil off the bottom, and then you do a couple of 100 mil off the top, and then divide up the space at 900 centres to see what's left. I'm not going to draw the other side because it's just going to be a mess of lines and it'll look ridiculous. Excellent. So we've got purlins and girts. What are they likely to be made out of?
Steel.
Steel, yes?
Which kind of steel?
Either. What kind?
Hot or cold? Cold rolled steel. Yeah, we saw them the other day. We saw them getting made the other day. We saw them pressing them in the machine.
But the cold is like.
Cold again.
We didn't see hot, so hot doesn't get processed in Darwin. The hot is the eye universal bin, the very thick steel that doesn't get processed in Darwin. But when we get into the lighter weight, the girts and the purlins, they can be cold rolled, so they come on flat, and we saw them going into the machine and getting pressed into C sections and Z sections.
When I thought about it, then it clicked me.
Yeah. It's alright, we can talk about it lots of times until it clicks with everyone. That's really what we do.
They
Cold rolled, that's them.
And they've got a little galvanised finish.
Yeah.
So,
We actually saw them going into the machine flat.
did you?
That's really good.
I'm jealous. This one's got a little bit of a twist on it already. Look at that.
Yeah.
It's not even that long and it's got torsion. So you can fix these to the universal columns, and you can have them sitting out like this, or sitting out like this. The Z or the C, and you can have them up this way or up this way. Which one?
I have it down.
Yeah, don't want to hold everything, do we? Yeah, it'd be hard to clean it out. And it would get full of dust and things on the inside. There's cladding on the outside.
Normally you'll use the C like this.
Wow.
There you go. So if it's on the roof, it'll be in there.
Yeah, vertical on the roof, yeah.
Vertical on the roof.
And on the wall, it's horizontal. Yeah, I should have said that.
Horizontal.
Yeah.
So you sit up or down, but
Yeah, so up on the roof, horizontal on the walls.
Yeah.
Now, how far apart are our bays?
Four, 7, 4, 7, 6.
6050.
Yeah.
I think maybe the open.
So a couple at 6 metres?
Are you going how wide between the columns?
Yeah.
Yeah.
4, 7.
So they vary slightly.
Yep, that's okay.
So between that 6 and 4, 7.
So
Slightly smaller.
this is 600 and it's got torsion. And we're asking this same piece or something similar to span 5 or 6 metres on its own. It'll be fixed at each end, so that'll help keep it straight. But what could we do for it in between those measurements where we don't have doors or above where we have the roller doors? What could we add?
So remember when you're standing in your warehouse, you're seeing the port frame,
Kinda.
you're seeing the girth, you're seeing the purlins. What else did you see?
The one in the
Mid-span.
Mid-span bracing. Well done. Excellent. I feel like I need another colour. Can I borrow your 4 square pen? Thank you. So I'm going to put... Lovely. Yes, you're right. Thank you. I'm going to put mid-span bracing. And what's that likely to be made out of?
cold rolled steel.
Yes. Well done. I love that. What shape?
C-section.
Something like this? That's quite substantial. That's the slab. Not that rondo stuff, that's too lightweight. Maybe not quite this heavy. Can we think of something that's somewhere in between them? What sort of cold rolled steel have we come across that is not as strong as this, but is stronger than Rondo?
You've already looked at it this morning.
Yep. 1.
Andy, go to the shelf there and bring me the 75 mil.
I thought that blue is
It's
for
blue.
that. It's just for weather protection, isn't it?
It's the galvanized, but it's structural.
Oh.
This side, Andy, this side, and this one. There's 75 mil. Yeah.
Perfect. That's what we would use.
The
You
blue
have
is
it.
1.2 mil wide.
They'll be all so
Look at Steve.
Just normal wall framing stud.
Smaller C-section.
Yeah.
We don't call this one a C-section. We
No.
call this a stud. 75 mil stud. So the C has these little bits that return down. See the way that doesn't? The C. This is more the C. C with the flick.
Sorry.
Did I do this for
That's all good.
Keep
Yeah,
that all the
now.
way.
Oh, they're on the recording. So they're all just jammed in together to show how the bottom
Yeah.
plate and the stud and the noggings all sit together, and then you bolt them or weld
so
them.
they bolted, obviously.
Yeah, bolt or weld. You can weld it. Yeah.
So is weld really like as strong as?
Weld is the same as the thing that it's welding to. To have a proper weld, the weld is no.
Welding
You're adding steel. It's not weaker at all. No.
Permanent.
Depends who does it.
One
Depends who
permanent.
does it.
Yeah.
And there is such a thing as spot welding, which isn't just
Yeah, that's not
spot welding is just where they go along and they
Just to hold it in
together.
place. Yeah.
But really a good weld that's fully welded.
So
Um,
would you go like weld?
Yeah.
all the way around.
Yeah.
Ah, right.
All the way around.
Yeah.
If you're welding this piece to this, you go. Oh, that's the inside. So all this side, all here, and all here, all the way around.
And there's a minimum thickness for the weld. There's a shape. You're not allowed to perish the amount of metal. You're supposed to bring metal in and add it. There's the trades guys over there learning that. It's very,
Yeah.
good job.
Well, that was like for uni artwork.
Ah, there you go. Yeah, I've welded a
It
couple
was
of things.
fun,
too.
though.
It is fun. Yeah, it's harder than it looks. So we've got mid-span bracing between all the spans of our girts and purlins, between the bays. Now I've probably drawn them where the doors are. Probably shouldn't have done that. Apologies. So just remember you can't put the mid-span bracing in the middle of the door, but there won't be any purlins there anyway, so that's okay. So what's next? Oh, and how are they fixed, just out of curiosity? So we've got this fixed to this or this. Any suggestions? Yeah, probably
No,
not
spot weld,
welded.
fully welded. Structural bolt, fully
It's
welded.
going to be a bit tricky. Yeah, probably a plate and a bolt maybe. Yeah. So it's just a bit of a connection issue there for the engineer to deal with. What comes next after that? We've got quite a bit of bracing, haven't we? But yeah, not triangulated. So we've taken care of the spans here, so there's not too much flexibility between the spans, but we've still got this whole building that could topple over if it was allowed to do so. So
we did note the other day that we were in the really big warehouse where they manufacturing steel. They had hardly any cross of the.
They didn't have that many?
And then we went over across the road and
They had
one
it.
shorter span and they had it.
Oh, really?
Yeah, I think all one side.
It was just one
Yeah.
side.
Yep. Was there a lot up under the roof maybe on that other
There was a
place?
lot of cross bracing, but less
Mid-span.
Yeah.
So on top of all of that, then you've got to add your cross bracing. Under the roof and in the walls as well. I'll exaggerate this by doing every bay, but that's a bit of an exaggeration.
They do like either like one each side.
Yeah,
Or
you do the
Yeah.
bands
yeah,
around.
Yeah.
kind of two.
Yeah.
or both.
Yeah. That's not going to be easy to see on this other side, but I'll put some in there.
Maybe because they manufacture the steel themselves, they just upsized all the purlins.
Yeah.
And need the mid-span bracing. I'd say that something like that
That's
happened.
quite possible.
Wasn't the cost to them. So the structural engineers trying to get all these members as small as possible because they cost less. So sometimes making this larger, you might not require the mid-span, but the cheaper way to do it is make this smaller and then use an even smaller bracing.
Mm. And then last but not least, the one last thing you might find is called fly bracing, which connects the underside of the purlin to the universal column beam.
Some fly bracing as well. It's great that we've already been out to see the building.
I think this is amazing, yeah.
Coming together, isn't it?
I might even make photos.
Yeah.
So that goes on every intersection on the roof where the purlins cross the universal beams. Every single intersection. And it might be plated and welded or bolted. Fly bracing, that's called, because it goes up. Terrific. Now we talked a bit about the gable end where the office is. This is where the support will come down under the rafters and we have the beam across.
See these other little universal columns that you've got in here? And that's starting to frame up this beam.
Yeah, that's where the office will go. It's just a little bit of extra support for the end. And then we've got the roller door coming off it, the loading bay coming off it. Let me just have a look and see if I can draw that. Oh my. Yeah, I really am.
The plan here, there's a UC there.
Yeah.
So I'm guessing the stairs would have to be, because it's not connected to the stairs aren't flush to the concrete wall.
No.
So it's going to have to be steel instead of concrete.
We haven't discussed the stairs yet, sorry.
We briefly discussed it before.
Oh, did you?
Yeah, we just went the steel or concrete.
Yeah.
Those are the two options.
Yeah.
Usually with concrete, the structure needs to be connected to the wall, doesn't it?
It doesn't have to be. No, the concrete can stand from
And we've got the toilet walls to support a concrete landing if we want.
Yeah. We decided we'd go with concrete because of the amount of concrete. We're already having a suspended slab. We can pour it all there. We can,
So we've got a centre column here already. This is the grid. So this column here is the one that's in the middle of nowhere. Sorry, everybody. Oh, all right. Yes, thank you. Yeah, apologies. Thank you. So the second to last, we've got the last grid here. That's this one, and there'll be a vertical supporting it in the back as well. You can see that there, these two at the rear in the last. So we've got support at the front and we've got support at the back as well. 1, 2. Then this is the farthest rear column, the very last portal grid here. That's this one here. And then we've got this other section. So see here the next grid down. Where is that? Am I bad drawing? Sorry. That is this one here. That one is here. And then we've got the next one, which is this one. Again, poorly drawn. Apologies. So that is where the little L section starts to head off in its own frame. So we'll have another row, and our roof changes pitch a little bit, doesn't it? And then there's another column, and another column to create that loading bay area. So same footings, same purlins, same girts, same cross bracing. Yep, we can brace that because there's nothing in the walls. Same bracing in the roof. Just 2 bays.
And it's not a portal frame.
Like Sandra said, a lean-to, if you like. Yep. A portal doesn't have to be pitched in the middle for it to be a portal. It can just go up and across and down. But in this instance, it's not a true portal because it's leaning against the existing portal. So it's just the columns, same universal columns, same rafters. It won't be any different. And then the same purlins going on and the same girts on the sides.
Very similar in its structure, but it's not a true portal frame.
Just an add-on.
It's just an add-on to the
Yep.
portal frame, leaning on it, leaning on the side of it.
Does anybody have any questions about that?
So for frames, it can be square. It can have a pitch. But with the square, it can have like a
Generally
pitch on
not-
one side as well.
You always have to have a pitch,
It's always a pitch.
so the water runs off,
Okay.
but it can be as low as 1 degree,
Yeah, that's
just not much less than that.
great.
Does anybody have any questions about the lean-to section? Can you picture it in 3D from the floor plans now? Excellent.
Like you're just bringing rafters.
Yeah,
from the
yeah.
photo frame.
So it's just the part that covers. You don't really have to address it any differently. Sorry to interrupt you. You don't really have to address it any differently than the rest of the structure. It's just part of the warehouse.
Yeah.
Okay.
It's mostly just for your information. Don't feel like you have to call it up anything specially. Yeah, yeah. It's mostly just for your own knowledge. Yeah.
And so, of course, you've got all the framing up now. And the last but not least, how do we have to dress the framing? What's that going to be made of?
Huh?
What's the roof going to be made of? What's the material?
I don't know.
It could
Maybe
be lots of, we
What's
just
the
call it
other-
a metal deck roof.
because
Metal
the
deck
bigger,
roof.
the wider one wasn't
The
it?
wider one's the trim deck, which is often used on large warehouses. We could just, at this point in time, call it a metal deck, and then, again, maybe consult with client as to the profile, the roof profile. So you have the option of having a different profile on the roof to the walls. Many warehouses, again, in the cost-saving exercise, will just use the same cladding. Will be on the walls and then come down, on the roof and then come down the walls as well. Do we need to think about anything inside the metal deck? Is there any other materials we might use on the roof and the walls in a warehouse?
Insulation.
Sisolation.
Sisolation,
Sisolation. Reflective foil. Sisolation. Anything else? Would we line it internally?
Well, we have to, wasn't it a requirement that if we had used isolation, then we'll use mesh? Or is that a
You have
requirement?
safety mesh on the roof, yes. And you could note that for commercial buildings you do need to have the safety mesh underneath the isolation, that's true. But when I say about internal lining, I mean, what do we look at when we're standing inside the warehouse? What do we see? Do we see plasterboard? Do we see a lining in there? Or do we just see the inside of the frame and the isolation? What did you see the other day?
It would be bare, wouldn't it?
It's just there, it's exposed. We have no internal lining. So you've just got a bare concrete floor, and you've got isolation to reduce some heat, radiant heat. You would not put bulk insulation in a non-conditioned warehouse or any non-conditioned space. Bulk insulation, like the blankets that we saw the presentation on the other day, the blankets or the rigid board, it has no effect if there's no temperature difference between inside and out. And the only time there's temperature difference is if we have air conditioning. If you've no air conditioning, you do not require bulk insulation. You're better off with just the isolation, the reflective foil to get rid of some of the radiant heat, and that's it. We have a couple of pedestrian doors in the facade. Oh, yeah.
Before we move on, can I just draw your attention? On the elevation, you'll notice there's a potential pitch already noted. So Sandra mentioned that you can have the choices between different profiles. The only restriction to profile choice is the pitch. So when you're shedding water, a custom oil profile sheds water slower than a deep pan profile like trim deck might. So trim deck, which is like somebody's heartbeat, the way I remember it. So it goes up and across and down, and it has a little kick, and then it goes up and across and down, and then it has a little kick. It's not all one piece, obviously, when you have it overlaid, but it has a very wide pan, and it sheds water faster as a consequence. Custom orb just goes up and down in roughly this kind of ratio.
That's what we call a profile,
The shape here.
the shape of the roof.
So this pitch can be flatter than this pitch. Now we have a 5 degree and a 10 degree indication as part of the sketch plans. Custom orb can go as low as 5 degrees, but no lower. So if you're going to maintain this pitch, you do have the flexibility. If for some reason the design brief requires a slighter pitch, or there's concern that in construction the pitch may become slighter or lower just because of the way the construction works out by mistake, then you might want to consider a deeper pan profile for the roof sheeting. Like Sandra said, different walls, different roof, no problem. So you could still have the aesthetic custom orb. It has a much, see the profile, it has crests, so you get that stripe, if you like, yeah? This has a stripe that's further apart. So it does work differently.
And if you're having a really large wall, a big expansive wall, sometimes the stripes further apart can look better because it suits the scale of the building more. Because, you know, custom orb is, while it's quite nice in smaller buildings and housing.
Yeah, it's quite little.
It's quite little, but once the scale of the building gets bigger, then your proportions kind of need to get a little bit bigger, and the trim deck can work much better on that because the lines are going to be wider apart.
So a 1 degree pitch is permitted for trim deck. Anything with a wide pan that can shed water faster, you can have a slighter pitch. Because the idea is if you have a profile that sheds water slowly and it's a slow pitch, then the height won't do the work. Gravity is not helping. And then the water just sits there for longer, and the more water you get, the more full the swimming pool gets, which is your roof. And then, of course, once it's full, it starts going backwards and heading up to the pitch of the roof where there is room for water to ingress. And you don't want that, because then once it gets underneath the roof sheeting, it sits on the isolation, and then your safety mesh can't hold it, and it all just comes crashing down. So you want to have gravity helping you if you've got small channels for the water. We've got very large channels for the water. It's just a bigger pipe, basically. Large channels for the water, it will shed faster on its own, so it doesn't need as much gravity. Any questions about that?
I can't even remember what the guy said. What was the length of the roll he
Yeah.
could do? It was 20 metres, I think.
Okay.
20 metres he could roll,
That's
and
the
that could
maximum.
fit on a truck. Does anyone else remember that?
Oh, I wrote it down, but it was fit on the
Not
truck.
12?
Yeah.
12 max.
12 or yeah.
Most
only
trucks are 12 metres, yeah.
maybe 12.
Anything above that, I think
no.
that's a charge, yeah.
Yeah.
You can get articulated lorries and things like that, but
can carry a bit
they
more.
are a bit of a hassle.
Yeah.
Yeah.
If you measure 20 metres, you could roll 20 metres or something.
Yeah, right.
But it was 12 metres for the truck.
So you have to get a bigger truck.
So we have to think about that when we want to have that one piece of steel continuous down the roof, you know, is our span greater than the 12 metres?
And then think about getting it up there.
Yeah.
That's a big piece of steel to raise
Yeah.
almost 10 metres off the ground.
Obviously want to get a crane on site to do
So
that.
then your safety and design, you know, if you're specifying a single piece,
Yeah.
how are you going to achieve that safely? It's doable, but it has to be planned.
On the display wall, there's a metal cladding sheet that is like in between custom orb and trim
Yeah,
span.
they had a
Yeah,
profile
there's
that
a
said
couple
some
The
of it.
metro span.
Metro
Yeah.
span, it was their
Yeah, that's the
own
in
one, yeah.
between.
Yeah, right.
Yeah.
Cool.
Yeah.
And did it have a minimum pitch?
Is it written
No,
on
it doesn't show the
Nothing.
minimum.
Yeah.
It just has a name. It's
Might
the
be.
It was
metro
quite
span.
shallow. I didn't
Oh, was
even
it?
know
That's
that.
probably similar.
Yeah.
And they had the mini orb there too. Which
Oh,
is
okay.
internal.
Yeah,
I mean,
inside,
you
yeah.
can see the mini orb,
Fancy.
it's like tiny little profile. There's no way you're going to use that.
No,
Right.
it's expensive. Really expensive.
But yeah, metro span.
To make it like picture wall inside though.
Yes, that's what he
Can
wants
you
to
mention
do.
it like a roof? It like look really weird.
Yeah, it would look really strange.
Now, typically when you have a portal frame, the structure does all its own work, and you wouldn't necessarily incorporate the overhang. You could actually have an additional piece added on.
Mm-hmm.
So it's the same member if you want that continuation of aesthetics. So this is the connection of the column and the rafter of the portal frame. And then we've got overhangs, you'll see on the elevation. We've got these overhangs here. They're different heights because of the different pitches and areas.
Got them over the roller doors.
Yes, and they have them over the roller doors as well. They'll probably be more like our awning that we talked about for them.
And really, this is like an awning too. It's just
It is. It's
fixed
just
to
fixed
the portal.
to the
frame.
portal.
It's not
Yep.
part of
Yep.
the portal
So
frame.
see how they're quite significant?
Mm-hmm.
So likely we're dealing with this kind of scenario where there'll be a plate and a bolt several bolts through. And it will cantilever
Again,
out
like
by
the awning,
itself.
It's just that one point fixing to the structure. You're just bringing it out. It's not like our truss roofs where the tails continued out. It's not the same member. There's a break in the steel there. It's two separate pieces and it's going to be bolted on.
And
Because the portal frame typically just does that. It goes out and down. It doesn't have tails. It doesn't
typically, they will turn the C section to have the back showing out once it gets there to create that facade that looks nice and neat as well. So it doesn't matter which way they face inside, but on the last one and this one too, if that's where there's a seal up here, then you'll have the roof sheeting on top of that.
I did a mistake of putting it the other way when I was doing roofing.
Oh,
Yeah. Well, I didn't know.
yep.
And then the guy, my supervisor's like, you want to come down here? Does that look good to you?
What do you think? Yeah. So then we've got a cleat connected to the top of the portal and bolted through. So it's usually a cleat and a bolt through to the purlin connection, and then just a direct fixing cyclone washer for the profile into the purlin. So it's pretty standard detail that you can include. And it will be all exposed outside. They don't typically clad it in or anything like that.
I have my own little folder of uni. So whenever
There
I'm
you
thinking
go.
of something, I just go back and look at it.
That's cool.
So if you didn't have this piece there and you're just dressing this and you've got your Z
Oh, yeah,
coming
put
out
the-
here with your big part
Do you want
coming
to do it? You know?
out. Okay.
Do it. Start up high.
C's all the way down here.
Yeah.
Good.
Yeah.
Girths, yeah.
And
And
then,
you're going to have your cladding. Let's say we...
yep. Perfect. And then you can put it up in between the awnings and
Yeah.
flash up and around it.
I'm going to pretend it's on
dotted.
in the background. We'll just flash it through there.
Yep.
And then this will be your roof sheeting coming down to here. Lovely. Got your roof sheeting there, and your roof sheeting will become, or your wall sheeting will become solid again here. And if that roof sheeting is just finishing possibly there, you just put a little flashing piece over it like that.
So that's in between the awnings.
A little barge flashing. We saw that on the, sorry, my flashing should have been underneath the roof sheeting. Terrible. Forget about that bit up there. Obviously, it would sit here underneath the roof sheeting and come down and lap over the wall sheeting. And that's just, when you look up at the buildings of the day, we could just see that flashing rim right around the top where the two materials join from the wall, or the roof sheeting to the wall sheeting. Just a little flashing coming down over that.
Touch.
Oh, really? Wow.
See you in an hour.
Almost
Almost finished. Oh, just a couple of things out for bitumen and drainage
okay.
and things. We've got a couple of services to talk about. Yep, not too much.
What's that?
What's her face?
I just wanted to go home
Ah, sorry. We could go another half hour. We'd be done,
Yes.
and then have lunch.
Fix the flashing into the
No, I won't make the RTA. That's
Hey,
come back.
you sure? Okay.
on the fly.
I think if you have that space, then
Yeah, you can do it.
then I'll kind of
But
I
yeah,
love
if,
internal staircases.
if you have like a tiny small studio and you want to still go upstairs, the most compact kind of stairs is fine, but it's like a pain in the butt to get things up there.
Yeah.
Very
It's a limited use.
not really pretty either.
Yeah.
Anyway,
A lot of
so
times
that's what
when
happened.
we're talking about the cost of constructing a house, people talk about the cost per square meter. So that's a very generalized way of costing a house. As we said, if you've got a floor plan that's turning lots of corners and lots of indents, the cost of that is a lot more per square metre. Even though the square meterage might be the same as your rectangular shaped house, the cost of that will be more, even if the square meterage is the same. So costing something per square metre is very general. It depends on the detailing, depends on how much complexity is in the structure.
I had a
I
client.
think that sometimes a rectangular shaped house can look nice.
Oh,
If
yeah.
it's kind of done the
Yeah.
right way, you
Absolutely.
know.
I had a client.
I actually like a rectangular house, but I love mezzanines. Like mezzanines make it so awesome. Like I love the
loft.
loft.
Yeah, because
the
that's
loft
a loft
mezzanine.
is the fancy word to
Yeah.
describe it, isn't it? Like
Mezzanine.
when they like describe real estate.
Yeah, I've always liked the loft, the bedroom, looking down over everything. It's like my kingdom.
I had a client that wanted turnout, I've called it. So this is the blockwork external wall, and they wanted to create a turnout, and this was to be where the TV cabinetry went in the lounge. So this is the main lounge area, and they wanted the TV cabinet flush with the main set of the walls. So they did a turnout for the slab, and I tried to talk them out of it, but they wouldn't have it. So it was an extra $7 or $8 grand just to do this bit. And my dad was the builder, so, no problems. So he did the slab out and then laid the blockwork around, so there was a little enclosure for the TV. The roof overhang was 900, and they went 900 beyond here, and it just ended up being, I think this was a 600, so it ended up being a 300 overhang for just the TV. So we didn't change the roof for it, which would have been even more expensive. We didn't change the roof. We just sloped that down a little bit underneath the roof pitch, no problem there. But they could have achieved exactly the same thing, because it was a side facade, it wasn't really a front facade or anything like that. It was an L-shaped house that came out, and this was the front over here. They could have done the same thing simply by using joinery. And just putting the joinery all the way across.
Yeah.
Simple as that.
And even if they could have put the cupboards there.
Yep.
You know,
So
for
this bit's cupboards,
storage.
and this bit's TV. It's very common. Fireplace, TV above, bookshelves, whatever. Joinery. So much simpler and flexible.
Yeah, because what if they don't like it and find it
That's
tiny
right.
anymore?
That's right. They're stuck with it forever.
Oh, yeah.
Yep. Pokey. Yeah, the TV doesn't fit. They get bigger.
Exactly.
Yeah. Good point. Anyway, so yes, there's lots you can do with joinery. Yep. Flexible, adaptable, wall framing, the rondo. You can take it down and put it up anytime you want. Yeah.
I recently did it. Wasn't obviously really project management, but I was about to go and look at a renovation, and they'd taken out all the old joinery. They were putting in new joinery. There was no wall between the two bedrooms. It's just been originally done with joinery when we took out the wardrobe.
So
Two bedrooms were just open to each other.
another story.
Back in.
Yeah.
Anyway.
Story time. So the donut house that my parents wanted, my mum, as the client, half the client at the time, was a quilter. So a sewing person, you make bedspread quilts. So the idea is you make a pattern with all these little pieces of material, then you put a big piece on the back, and then you join them together using a quilting machine. So it's a big machine. It's about from here to the wall long, and it rolls the material through and does a sewing pattern over the whole thing to join the two together. It's a quilting machine. So that was in the brief. Because when you want your dream house, you've got to have what you want. So this is the pool room for the pool pump. Then we've got a laundry, sort of here. This was the master suite. Bathroom, main bathroom, bedroom, garage. This is living and the kitchen. And then this was, the garage came up here, and then this was a bedroom here. And so 3 bedrooms, and my mum said open. Yeah, this is inside outside.
Yeah. So was there like a little veranda thingy here?
No, just all the doors open straight out.
Okay. So
straight out into
if
it.
If you wanted to go from here to there, then
you walk through this space.
And you'll get wet.
No, it was roofed. Roof over the whole thing.
Oh, it is roofed.
Yep, over the whole thing. So the resolution of the brief was where we're going to put this quilting machine for my mum. It couldn't be in the living area because that's just daft. So she wanted to put it in the spare bedroom. So this room here doesn't have a wall between the laundry and the bedroom. It's just joinery. Exactly the same. So there's a robe recessed So it's flush with the wall. The robe is recessed, so the front glass of the robe is flush with the inside wall of the bedroom, and then the cupboards in the laundry face the other way. And they just back onto one another. And when she was finished with this bedroom and the quilting machine that poked into the laundry, we just put the joinery in. Crazy, huh? So there's no wall there. That would be a surprise to somebody who took joinery out and went, oops, no wall. Yeah. So there's a reason why we did it, but I don't know why they would have done it. Yeah. Crazy, huh? Yeah, but you can just back join it as long as the structure works. Just joinery.
Because my sister-in-law just bought a house and laundry cupboards, kind of like, I think that the back part has come loose, and I think it kind of touches the gyprock or whatever they use for the bathroom.
Yeah.
Like just like
backs right up to it.
You can access the inside of the wall. That was like, I don't know, is that normal?
So the back of the joinery was the cladding for the wall.
So there was no gyprock basically, or no.
Oh, okay. They're using the joinery to clad the wall.
Yeah.
The back of the cupboard is the lining.
Yeah.
Ouch.
Yeah.
Yeah, that's
but
not
it's
good.
an old house.
You find all sorts of things in those houses.
Yeah. I've got a past student whose builder put the floor waste in her bedroom instead of the laundry.
Oh my god.
What
a rug.
Oh no.
Oh my god, I'd be so mad.
So they had to seal off the floor waste and take it out of the the bedroom, but they didn't put it in the laundry, so she has no floor waste in the laundry.
So what happens when you don't have it? Because I don't have it. And what do I do now?
It just floods.
But it doesn't flood. But well, yeah. But
it's an emergency situation.
In terms of like certifying, because so you don't get it certified or like did they say?
I don't know. I don't know.
That's what like.
Yeah.
It's a long story.
Yeah.
The bathroom downstairs in my house was obviously added on underneath the elevated part of the house, and it had no floor waste. But when we did the renovation, we did put a floor waste in because the plumber wouldn't sign off on it
without
the
it.
second time. Without the floor waste, so we had to put it in. So if you ever
end up paying for somebody else's mistake.
Put it in. But it was.
I have to say that this course has been like a huge eye-opener for me because obviously like the renovation that we did is the first one ever for me, I guess. And I had no idea about that.
That's so bad.
I'm embarrassed about it.
So many people don't.
And then you hear like, the tiler said that, if you don't have the floor waste, then if it's an old house and you don't have it, then you don't have to add it.
You don't have to upgrade
if you're
sometimes.
Not changing the location of any of the fixtures and fittings, then you don't need a permit. Well, waterproofing is a questionable in there, retiling and all that stuff.
Yeah, that's what we did, retiling.
That's only what we did. You get the waterproofing certificate, but if you're not actually moving any fixtures and fittings, it's very grey area. It doesn't really come under the permit.
Because you're not expanding the floor space.
Would it like just changing a bend on a pipe instead of you went like that way?
No, if you're not adding a new fixture or fitting, it doesn't
it's self-certifying, so that's okay.
So
If you're adding walls, so if you think about the NCC, if you trigger anything to do with the NCC, if any of the rules we've covered at the NCC, something about that attribute changes, then you're probably going to need a permit.
Yeah, no, we didn't. We basically did the there was it already was built in downstairs and it was concrete floor and we just tiled it basically. And the bathroom, there were existing tiles on the floor and we tiled over top of them. And then I think we removed some tiles from the wall and then everything was tiled. Obviously that waterproofing should be certified, but I think we can get it. I think we can get it.
I don't think you would have triggered a building permit at all, because that's really just finishes.
Surely.
It's just finishes. When you just do finishes, replacing like for like, doesn't trigger a building permit.
Yeah, you're allowed to renovate your own home.
But thinking back now,
you add walls, take walls, change openings, doors.
Internal walls.
Internal walls not so bad, but then you're changing.
You're okay.
But as soon as you add a window, you have to. And
structural
also,
work.
Just a question about insulation. That's also part of NCC, isn't it? So
it is. It's part, for housing, yes, it is. It's under section 3.12.
The builder, I didn't see any insulation put into our
doesn't surprise me.
Yeah.
It doesn't surprise me.
Unless you ask.
Builders don't know the NCC. back to front at all.
No.
At all.
But I think we should have had plans, so that's what.
You can't get a building permit without having
Yep,
plans. done.
without something to
There's
stamp.
so many people think that they can go directly to a builder and just pay the builder and get the work done.
Yeah.
They
And the
don't
builder will take your
know-
money.
They don't know about the whole system.
They will.
And all
Yep.
of that. The problem is that if you go to sell your house and you've made changes without having appropriate permit, when the buyer
inspection
does
report will
an
trigger it.
inspection, it will come up in that report that is uncertified work. And basically they want to knock the value of that work off the price of the house.
And charge you extra for the value of having to fix it.
Interesting with my daughter-in-law, sister-in-law. She bought a house and they discovered there were a few, like I think it was like one of the sheds wasn't certified and there were some other little bits and pieces that weren't certified. And then when came down to like conveyancer to say that okay, you have to take 10 grand off the price, sellers said no.
Oh,
And
yes.
they didn't.
Seller doesn't have to.
No.
You can say no, but then they can
They won't sell.
That's the buyer.
Yeah,
That's
but they
the
didn't
sale.
seem to worry
No,
about it. So
no.
I think in the end that it still went ahead. But I was just like,
If that was the
no,
market
I
a couple
wouldn't
of
have
years
done
ago
that.
when houses were in short supply, it was a seller's market.
Yeah,
Today,
yeah,
can
now
I
you
tell
couldn't.
Yeah, that's
They'd be
right.
saying, take the money off, or I'll just go and find another house because there's so many on the
There's
market.
so many, and the particular was that the not Barclay, but the similar one, but called different.
The Gorlo.
Yeah,
Yeah.
So there's like Tiwi's full of them, Manula's full of them,
Yeah.
Wuladi's full of them.
Yes.
That's what I can't.
Goodness me. All right, so where do we get up to? We did the roof sheeting, didn't we?
Yep.
And we've connected the old to the new, and we've done the little L shape where the loading bay goes. We've got the isolation. We've done the mesh, the safety mesh. We're not ventilating the roof. We've got roller doors. We've got windows, aluminium frame windows. We've got regular doors. They'll have steel frames, same as normal, except it'll be welded to a frame within the girts. And you'll have solid core timber doors as your
You might
standard
have
doors.
solid metal doors on them.
Yeah, that's true. They might be metal frame.
Metal frame.
So they can be built in the hole, or they can be purchased and prefabricated, but they're just a small 50 by 50 SHS steel frame with a rectangle that has the hinges welded to it, a couple of horizontals, and then a little timber bit in the middle to hold the door handle. For the door.
The doors,
Yeah.
the pedestrian doors, these
Yeah.
smaller doors. We already talked about the roller doors, but these smaller doors on a warehouse would quite often are metal frame doors, just for durability and strength.
Yeah. And then you simply just clad the whole system in ColourBond coloured sheet.
Or they can often be just done with a flat sheet. The doors.
Yeah, just flat. Yeah, no, I don't mean a profile sheet. Just flat sheet with a ColourBond colour, or powder coated, probably powder coated. So this is all steel. It's just a big welded frame, and then some stability, and you might have a cross there and a cross there, and this bit is timber, and it'll just have a little plate welded to it, so that you can drill a hole for the handle.
How much timber have you got in this project?
That's the only bit.
That's the only bit of timber.
Yeah.
What about termites? Do we need it or not?
Do we have to have a termite management plan?
So if there's no timber used, you don't have to.
No susceptible materials.
Yeah. So with AT2, we don't have to.
AT2 has a bit of timber, just in the doors and things and finishes and things like that, but less of an issue there too.
Right.
Yeah,
But we didn't go through that.
a lot less. No, we didn't. It was on the NCC thing.
It is on there,
Yeah.
but I was wondering
Remember that
about that.
crappy flow chart that they had where it says, do you have termites? Have a plan. Do you have termites?
Yeah,
No,
yeah,
don't have a
yeah,
plan. The world's most obvious flow chart.
Yeah, but that's
Fantastic. I didn't know they could be funny, but they are.
Yeah. If you have no timber, you don't need the termite management.
Yeah. Flat steel cladding.
I always do want termite management though when it's residential because people have flat furniture.
Yeah,
What's
yep,
the other timber?
yep.
And so my personal rule is residential, I'll have it. But if it's a steel structure, it's a warehouse structure, if it's just got no timber in there, be careful. If you did use ply on the flooring for the first floor, you've got timber. That's a structural timber. But this little piece of timber in the door,
No,
you wouldn't worry
and
about.
it's fully enclosed.
Yeah.
Yeah. So it would just be a big sheet over the top, and it would have a little round It would just go to the sides, and then the other side would be the same, and it would just get fixed on the outside. Spot weld it, like Sandra was saying before.
So the doors, the pedestrian doors, will be metal frames.
And the same windows, so aluminium frame, powder coated glass windows. We've got some guttering on the elevation. They are collecting some of the runoff, but it's not on every elevation. If you have a look at the elevation itself, you can see there's a little downpipe and a gutter for half round. See that there? So just here, and then that's the other side of it. So it's only on one side. Which side on the floor plan is that on?
That is on.
If you can orientate yourself, just point. Which side are these elevations referring to?
That is on the L shape.
The loading bay, where the
loading
parking
bay.
spaces are.
That one there. That there.
I know you know.
I'm gonna go call it.
I know you know one. My club. Spatial awareness to the max here. Use your own drawings. Work it out. Take the time. Take all the time you need. It's really important. Have a look at the elevations themselves. Have a look at the features that are on that elevation, and then find those features on the floor plan so that you can match them up. It isn't easy, but it's an important skill. Where are the gutters? You have it. Where do you think, Andy?
Here or here?
Here or here?
Maybe here
Hmm? Just in one spot?
and this one.
Yeah? What's in those spots?
Loading.
So which part of what you're seeing is in those places? And what's between them?
No, oh yeah, this one door.
Yeah.
Finished?
They've got, yeah, that's it. You have it. Good job. So then this is here, all the way along and down in both places. Yes, Andy's got it. Has everybody got it?
I've got one on
Yeah, just the one little spot. Yep, you found it? Yeah, it doesn't go all the way, does it?
here, but it appears on the other.
On the other side of the elevation.
Oh, elevation, look at that.
Yeah, just on the back side. Adriana, did you find it? Yes, lovely. Sharon, you found it? Everybody got it? So, and you can even see there's little downpipes on the floor plans. A bit of a giveaway. I didn't see that. Oh, you could put DP next to that. Yeah. Downpipe. Yeah. Oh, sorry.
Downpipe, DP, beside those little circles.
Yeah.
And they should appear on your floor plan. Anywhere there's a downpipe should appear on your floor plan. Why do you think they gutted that side and not everything else?
Right out of my mouth. Why did they put them there?
Do you want us to answer that?
Yeah.
Okay, the landscaping's on that side, and we've got some,
Oh, is it?
yeah, I thought that, so I thought maybe some water can go to that. I don't know if it's going to be grass
And
or
it's
it's
out
going
of
to
the
be the pebble.
way as well, where
There's no,
Oh, they've got...
there's no cars there going, there's no foot traffic that way, so somewhere to put all the water where it could be used, I guess. as well.
You think they'll let the water go there?
No,
On the
let it
ground?
go there.
no? Do you think that there's something
Don't know.
to
Think about the boundaries.
water?
With the boundaries of the whole site, have a good look around.
It's
Yeah,
a lot of water.
yeah,
Yeah,
doesn't go over the other side.
yeah.
This point of the building is probably closest to the boundary. Generally, when we're getting close to the boundary, we gutter so we don't inundate the neighbouring site. So we're not allowed to put our stormwater onto the neighbour's site. And because there could be quite a volume of water coming off that roof there. The chances are, because I don't know what this is, but maybe a metre, metre and a half.
Yeah, we said it was between 1.5 metres and 3 metres, so it's not
somewhere
far.
along there, that the chances are that we could inundate the neighbour site there.
Yep.
So we have to put it into a downpipe.
Yep. Now, there's no other proposed guttering anywhere else. So what that means is under rain conditions, all the water will shed directly from the edge of the overhangs wherever they find themselves. So the awnings will shed water, the roof itself will shed water, and it will simply just fall directly to the ground. Don't want to go into too much without one because he'll miss out on this. So we'll just make ourselves, oh, here it comes. Excellent. Just wait 2 seconds. So if we've got guttering on this little edge here to prevent inundation for the neighbours, we don't want the water to spill out in that place. And like I just said, there's no guttering elsewhere, so the water will simply fall to the ground. Now you can see they've got landscaping planned where the landscaping is required. I don't know necessarily that this will end up being completed. That might be just a nice idea, but there's an easement there. It's okay to have low shrubs, but access is then restricted for the emergency vehicles that we were talking about, so it might be just a bit narrower perhaps. I'm not sure about that one. But it is able to be a porous surface. This area here down the easement, I would recommend in my report to leave as a porous surface. Now that's good because it's an easement, and if they need to dig it up, they're not digging up any of your concrete or paving or construction. But the other benefit is it does allow penetration of water. So any water that comes off this whole side, see how there's a ridge down here, and this whole half all sheds this way. All the water will fall from this half of the roof down this way, straight off the edge, no capturing by guttering, and onto the ground. So to have a porous surface there, and I suspect what you would see is what's called a spoon drain. So a drain just carved into the dirt that falls towards the road as well. So I would recommend both a porous surface and a spoon drain. It's just a very small, so here's our surface, and it's just a divot in the ground. It's just a carve out of dirt. The grass would then be allowed to grow back into it, and we just call that a spoon drain. Because it looks like a spoon, see? Mm-hmm. So a spoon drain, and it would be falling towards the road. I'm going to write that on here because I didn't have it. So P-O-R-O-U-S, porous material, and spoon drain with a fall with an arrow. So it's just a dashed double line to indicate this edge here and this edge here. So I've just done a double line on my site plan, on my proposed layout. With a spoon drain, I've just written porous material, spoon drain, and fall, and then an arrow towards the road. Just in case there's so much water that it can't sink into the ground fast enough, the spoon drain will help move the water towards the road, which is okay. So that's taking care of pretty much half the building. That's terrific. What are we going to do with the other half of the building? What sort of ground surface do you think this area is going to have, where the car park is and the driveway and where all the trucks go? What do you think? Porous pavement? No, probably not, because it's going to have some heavy vehicles, and so we want a very stable surface that is not going to push you, that is not going to give way or create holes or cracks or crevices or anywhere that anybody can damage. So what material, surface material, do you think we should apply to the car park and the driveway area? Bitumen? Yeah. What do you think? Bitumen? It's extremely hard wearing. It's reasonably economical. It does hold a lot of heat, so that's a shame. But I think that's something we're going to have to deal with, because I think as far as serviceability goes, it hits the mark, doesn't it? Yeah. I don't want to shut you down completely once, so feel free to just pop up anytime you like. Yeah. I'm like, oh yes, but no, yes, but no.
I'm listening to you here on.
Good.
What service, sorry?
Pardon?
What service?
Bitumen. So the surface, it's called bitumen, yes. B-I-T-U-M-E-N, bitumen. I think it's also called asphalt. Yeah. Asphalt, yeah, you know it? No? So every car park we've got, all the ground, that black, sticky asphalt, yeah. Bitumen or asphalt. So it's black, you know it?
That's the one we use for the road.
Yeah, just the same as the road, quite right, yeah. So it's rocks mixed up with a sticky tar and then it sets in place. And when it's really, really hot outside, it does get a little bit sticky again, but it has to get pretty hot for that.
And bubbly.
Yeah, yeah, a little bit bubbly. But what does bitumen do that our porous surface doesn't? It does. It will collect all the water. So we've got this half of the building shedding down to a nice porous surface, and our spoon drain will take it out to the road. Brilliant. But this half of the building is going to shed water onto a surface that's impervious. It will let the water sit on top. So if we're not careful, we're going to end up with a swimming pool where our cars go. We don't want that. So one of the first things that you'll have to include is some drainage in the ground. So you're probably looking at what's called a sump drain, and you might need two because it's a lot of water. So as the water comes off, it's not gutted. So what we need to do is have the ground fall towards the sump. Now I talked about sumps the other day. They're a big pit in the ground where water can collect. There are pipes into that sump that link up with the stormwater system. And the sump allows for overflow should the system become inundated fully. But we're going to need at least two of those, I think.
Is it S-U-M-P?
S-U-M-P, sump. Sump pit, you can call it. I think on our landscaping design, we definitely need to have a couple of sump pits. Then they are connected together and out to the stormwater system. So the groundwater, the rain will hit the ground and collect, and the rain will hit the ground from the roof and collect. And they will drain towards, like a big plug, like having the bath plug. It's just the same, except there's no lid. All the water will drain to these two pits. There will be big pipes inside them, and they'll allow the water to travel downwards and out to the stormwater system. If you're going to have a bitumen or asphalt surface, you definitely have to provide a way to drain the floor. The other option is simply just to sheet all the water out the driveway, but that's a lot of water. I think too much. I think that would be irresponsible. And nowadays, if you wander around into car parks, you'll see them all the time. Now we've brought them up. You'll be like, oh, there's one, there's one, there's one. You'll see them everywhere. If you have, in the planning scheme, if you have more than 50 car parks in a car parking space, you also have to have an oil separator inside these because there's chemicals and oils and things, and we don't want that going into the stormwater system. So it's a bit like an oil separator outside a commercial kitchen. They have like a grease trap, and it traps the oil and stops it from going into the stormwater system, and then they come along periodically and empty it out, which is a pretty gross job. Fantastic. So we talked about getting the water away, but we've got to bring some stuff in, don't we? What do we need to bring in? What services do we need to bring in?
Power, water, sewage, communication.
Yep. So we've got our dial before you dig capabilities. All the services are provided in the street here. We don't have to generate our own services for anything. You're probably looking at a fairly substantial communication data plan for the office. I don't think you necessarily need to worry about servers or huge battery backups, but some offices do require uninterrupted power supplies, a UPS, an uninterrupted power supply for their data and communication systems. So if that's the case, it would just be a matter of making sure that it has the right capability. So it's usually a battery. It just feeds off standard 240 volts. You don't have to have three-phase power for that. But in some manufacturing warehouses, so this isn't one of them, but in some industrial complexes, they need more electricity than a domestic supply. So that's a three-phase. So that just allows more electricity to come in, larger wires, bigger connections, and a higher rate of electricity. That's not the case for this one. Just keep that in the back of your mind. So you'll connect to, there'll be a meter board, probably back here somewhere, if I had to guess, out of sight. Connect to the electricity, bring in the telecommunications into the same place. Very same as domestic. I mean, power to meters, telecommunications to meters, water to meters, it's all the same. The water meter, I think, is over this side, but you'll have to double check on the dial before you dig. So electricity on this side and water on this side, if I'm not mistaken. And the services just go directly across the drawing to where they need to go. And the water will probably go back to this point here somewhere. Probably to here, and then it'll go to both places. So there'll be an outside tap here.
What is this here?
The meter box and the NBN.
Okay.
Just one above the other, the same as in residential. Sometimes you have overhead power, so the power won't come in from under the ground. It'll be over the ground. There'll be a pole connection, so we might have to just double check. If that's the case, then the wires will go across to the side of the building on the second story and then go through the building that way. Come down into the blockwork, through the blockwork, and then go into the portal frame shed from there. So just check on Google Maps to see if there's overhead power lines in this location. It's still a direct line, but it's just above ground instead of below.
So these are for our report, the drawing would be something like this.
Exactly like this.
Okay.
Yep, use these ones.
Yeah.
Yep, just submit this.
Mm.
And we have to describe also that, like, when we do a report, that such and such services are required, and then as per going...
So it'll be, they're called reticulated, so they're provided by the council, and the services are reticulated, they're already there in place. You don't have to provide them. So it's a reasonably straightforward description to say that you'll be receiving the services via reticulated council services from the verge out the front, and then connecting them to the building using the certified practitioners. What lighting do you think we could have in the warehouse? Let's have it.
You're right.
Yeah. Can't even hold it inside.
I was gonna
Wait.
Yeah. So has anybody ever turned on a light and it hasn't come on immediately?
Yeah.
It's taken a while to warm up?
Yes.
Yeah, what are they? They fluoresce?
That's
Yeah.
what I would say, yeah.
I think they're halogen. Yeah, yeah. You know those dome ones you see in Bunnings? I'm pretty sure they're halogen. They do emit a lot of light. Now, something that I would really like you to research is a company called Solar Tube. Solar Tube, yes. Yes, we are going to need to have artificial lighting for when there is no light, no natural light, but it would be terrific if there was an abundance of natural light available. So quite a new...
We forgot how to spell.
Fluorescent. Oh, I understand. F-L-O-U-R? No?
U-O.
U-O. F-L-U... Oh, yes. F-L-U-O-R-S-C-E-N-T. Fluorescent? Yeah. Yeah. I think that's right. Fluorescent. I can't guarantee that's correct now. I'm not sure.
Double check.
Yeah, double check. I'm sorry. So Solar Tube have a product. They have quite a few products. One of their main products originally was roof lights for residential homes. So they have a little dome in a square plate that sits in the external roof surface, and then a tube that comes down, and then another system that sits in the ceiling. It's just like a little plastic square. And the sunlight that's outside travels down the tube because it's reflective, and it bounces around in there and comes out, and it shines, and it looks like the light's on. So if you've got an internal room like a pantry or a laundry or something that doesn't have any external walls and there's no natural light, and you're always having to turn the light on, you can use one of these solar tubes to introduce daylight into an internal room or a dark room quite sufficiently. So it travels through the ceiling and the roof cavity space. We don't have a ceiling cavity in our portal frame shed, so it's a different product, but it's the same principle. It has a big square that sits within the roof sheeting, and it allows natural light to penetrate the roof ceiling and the roof space, and it can be extremely effective for daylighting. They call it daylighting. So you're bringing daylight in instead of having to use artificial lighting. It's a huge cost saving to the consumer. So I'd really like you to research potential for solar roof lights so that the daylighting can be brought in for the client and see what that's like. Because the offset of daylighting compared to the electricity that you have to pay to run artificial lighting could be worth having. They do have a product that does filter out some of the ultraviolet light. So we just really want to keep that out.
The shed that we went to, the warehouse, had the transparent sheets.
Yep. Yeah, they do, and they perish. Yeah, I'm not a fan of them. We do have some laser light examples that you can get, and they don't last, forever, but they're pretty good. They come in the same profiles. We got a whole bunch of them. There's nothing we don't have. Sandra?
We could build a little bitty house.
Yeah, we could, couldn't we? Thanks. It's not too bad.
Obviously, you need
would that
to.
be a cheap alternative?
Yes, it's cheaper.
It's cheaper than roof
You
lights.
just replace
that's for
one of
sure.
your sheets with the ample light.
Yeah.
Sorry?
Oh,
no,
substitute.
Just substitute.
Oh, okay.
Yeah.
Sorry, that was it. So yeah, just say where one of the sheets would have been, you just run
Yep.
from this.
Yep. I don't think that would let much light through, but it's a lovely shape. So there's all sorts.
This one then.
I don't know that one.
Like, it's like fiber mesh.
It is a composite material, you're quite right. Trapezoidal shape.
So you got to make sure that you can find this product that matches the profile of your roof sheeting because it's
Got its own shape.
Roof sheet.
Yep.
It has to be the same profile.
Yep.
But that doesn't look very
No.
durable.
No.
That's why I'm just thinking if you put this one on your roof, then
It's all right for a domestic patio or something, or, yeah. I mean, you use it for balustrading, but it's not impact resistant. There's not much you can do for it with it, yeah.
I haven't used very much of this.
No. So investigate daylighting options, but fluorescent lighting for the artificial is perfectly fine.
wouldn't this be fairly flammable? Like you would.
It wouldn't last long under fire.
Yeah.
It wouldn't necessarily spread the fire, but it will melt really quickly.
But that's what I'm like. Yeah, it would melt.
Oh yeah,
Yeah.
in a second. Pretty cool, huh? Oh, matches. Oh, they're not matches. They're little seeds. You plant them to grow lettuce. It's just a gimmick. I don't know how. Didn't mean to pick that up. There you go. Grow lettuce. All right.
Would it be like
They've been there for ages. I don't think.
Yeah, they're probably, nope. So split system air conditioners for the office, just size them up as well. So while you're sizing up for the class 2, size up the split systems. solar tube lighting, well, it's not tube, but the solar day lighting for the warehouse, and big ass fans, look up how much they cost, what the installation techniques are for those, look at the technical specifications for the fans. We've got about an 8.5 metre high ridge height, so there's some room there for the fan because the pallet racking will probably only go 3, maybe 4 metres at the most, so there'll be plenty of room for a fan in the portal frame shed. Don't forget to look up the deemed to comply number for the cladding, for the walling and the roofing. Got to include that in your report. And the cool thing that you'll be looking up to is the fire rated door between the warehouse and the office. Look up what that would perhaps be manufactured like. So who locally could provide that, if available locally, and what we would need to be able to do. So they would be automatic closers with the fire rated level of nothing 9090, -9090. And the front doors. What kinds of doors would you like for the front? So we haven't specified them, we've just said aluminium frame entrance doors. You can recommend to the client some fancy doors. Automatic is good because then they close behind everybody and keep the air conditioning inside.
Or self closers.
Yeah, yeah,
More
yep,
cost-effective
yeah,
in there.
yeah.
So you wouldn't have a door that would just stay ajar.
No, you don't want a door to stay open all the time.
To get up every 5 minutes to close the door again.
You can get a curtain, air curtains. Have you ever walked into a shop and you've been just like a waterfall of air just hits you?
Yes.
They're called air curtains. So they're not air conditioned air, they're just air being forced down where the doorway goes, and it just keeps the cooler air inside a little.
Really?
It's not super effective, but it does work.
You're not
They're called
talking
air
about
curtains.
this one with the plastic one.
No, just air. So there's a blower at the top of the door, and it just blows air down in the doorway, and it keeps the temperature difference to the side as best it can.
Okay.
Yeah, we're not looking at that. It's the thing, but I don't think that's necessarily a good idea. Very
I really
inefficient.
appreciate them in Ireland when it's really cold.
Yeah,
You walk into the shop,
and you keep the warmth
Oh,
on.
yeah,
Oh. Keeping the door open for everybody else, of course.
I know the heat ones.
Yeah, the heat ones you really
I
notice.
remember.
Yeah.
Yeah, right. So you can get the hot air ones as well, can you?
Oh, yeah.
Oh, I didn't know that. That does sound good. So, we talked about bitumen or asphalt and sump drainage and connecting to the stormwater. We talked about either underground or overhead power in, probably overhead in this instance, but we'll have to Google Maps it and just see what's available. Dial Before You Dig will tell you where it is, but you just have to look on a photograph or do a site drive-by to see if there's overhead power in that place. I don't know, to be honest. And then we talked about daylighting in the roof. There is a product on the market that is sealed car parking flooring, but it is porous as well. So I don't know if that's available here, but if you're interested, I would love to see that in your report, if you're able to find out whether porous surfacing is available. So in the rainfall we have, no system would be able to keep up. So we would still need the drainage, no matter how good the porosity of the surface was, so porous concrete or asphalt was, we would still have a build-up of water in the rainstorms we have. So we would still need it, but if by chance some of the water could go through into the groundwater, that might be a good thing. We just have to be careful because it's quite compacted clay soil and it may not necessarily absorb the water fast enough. So, you know, but it'd be interesting to see if it's even available. That's the list for me, I think.
Sorry, what are these called again?
Sump pit. Mm.
Maybe just some clean bread on the outside.
No worries, we're done. Good on you. Yep, we're all finished. Perfect timing. Can anybody think of anything else? When somebody says, oh, I just want a building, now you'll realise that no such thing.
They got the back fence here.
Oh,
Does
yeah,
he
the
wanna-
fencing?
Yeah, does he want to strip that to connect it to the front
No,
of his other building?
not
No.
necessarily. I mean, you could mention it if you want.
Yeah.
Yeah. It's kind of a maybe I will, maybe I won't.
So he's going to keep it as two separate warehouses.
Yeah.
Okay.
You did the car park calculation, did you?
We had already done it
Oh, you've done it.
for planning.
Oh, yeah.
What we haven't talked about is
Oh, yeah.
the Australian standards for car parking, AS2890. Write that down, 2890. Yeah. So that covers the disabled car park. So we talked about making sure that there were 10 car parks, but number 9, I've called it number 9. Number 1 for you, Birgit. This one here. We were making that the disabled car park, so it needs to have space for the car, and then there needs to be a space next to it to be able to get in and out of the car. So I've drawn it where the shared space is on the right. Sorry, not the shared space. I've said so the car park itself is on the right and the bollard space is on the left. But when I think about the fact that the disabled person is likely driving the car, making it to the right would probably have been more preferred. But basically, for a disabled car park, if I just draw it briefly, the idea is that you have a place for the vehicle to go, and then you have 2 spaces that you need to keep clear for the disabled person and their equipment. And you put a bollard here to stop people parking there. So this is the space where they park. They have this space to use or this space to use. Now you don't have to mark this out, it just has to be clear. Most car parks have a space behind them clear. But you don't want to have such a tight driveway that if the person is coming out of the back of a car with their wheelchair, that they can't get out without being hit by the driveway traffic. So that's just a bit of a demarcation where you need to give them a bit of space as well. So there needs to be some width in the driveway. So you'll see here on mine, I've just got, and on retrospect, it's not wise to put it on the left, but I've got a little space here with my bollard, my disabled car park here, and then the shared space. And because it's tiered like that, the shared space actually just tucks in really nicely underneath it. It doesn't stick out on its own because it's not a 90-degree angled car park, so that's quite convenient.
It's also a minimum width you need to have your road coming into it. Angled car parks is,
I think it's still 6 metres, but it's just from the nosing line.
yeah, from the nosing line.
Yeah.
Slightly less angled. Regulations. Depends if you've got a one-way system going on or not.
Yeah, we've got the two-way, I think. Yeah. So the driveway needs to be 6 metres, and again, AS2890.6. Two-way driveway. So in the planning scheme, it's got 6 metres for the crossover and the driveway. And you can see there's a drain underneath what would be a fence and perhaps a gate. And you might say an automatic gate. So there's what's called an ag drain there. So remember we talked about having the fall towards the road. That would still be the case even though we've got the sump pits. So any water that falls to the front here that's beyond the sump pit would then collect in the ag drain and then go into the stormwater system as well. So it's just an open grate on the ground level with slats in the top of it, and the water goes in and then it's falled towards the stormwater system. And we call it an ag drain, this one here, and it would just hook into the stormwater system. Yeah.
Ag.
Agricultural stands for. It's just short for that.
Call them a cattle grid.
Cradle grids, yeah.
Cattle grid.
Yeah.
Did
The
2
railroads
jobs.
are way bigger though.
Yeah.
But that's about
Well,
keeping
we
the
actually had
cattle out,
well,
yeah.
I didn't know that at all.
They used to make me nervous. I think I've had my ankle caught in a few of those. Does anybody have any more questions?
Happy to write your report on AT3.
So obviously that would be concrete.
Yeah, just bare concrete, the floor. Yep,
So
nothing fancy. Don't forget you're looking up the roller doors as well.
So for, let's say, roller doors, windows and things, so let's say are we going to specify like a brand or like a
You
type
can,
or
yeah. Something that's available locally
yeah.
and that's cyclonically rated.
Mhm.
Absolutely. I'm just going to stop the recording and I will photocopy all of these sketches for everybody.
Awesome, thanks.
It's okay to draw them yourself. Oh, so many sketches. There's one on the back of that one as well. Thanks, Sandra. And then Andy and Adriana. Yeah. Better stop this recording. It's 3.5 hours long. Oh my God. What time is